Good morning, everybody. So here's the session regarding the RapidMiner 3. So we have completed 2 sessions before. So let's see what we have discussed in the previous sessions first, and we'll move on to the new ones. First, we have seen introduction to RapidMiner. RapidMiner is the tool which we are working on. And then how to download and install one of the product, which is RapidMiner Studio. And then we have also seen how is the interface of that particular application is looking like, and how to just use the data which is inbuiltly present in RapidMiner, and also how to use or how to import the data from outside or from your local machine or from the database. We have seen all those things, and we have completed EDA also. And let's see what is present in the second module that we have finished. So in the second module, we have seen what is probability and what do you mean by random variable and what is probability distribution, and also inferential statistics. And regarding the EDA exploratory data analysis, which contains 4 measures, but one is measures of central tendency, which consists of mean, median, and mode, and measures of dispersion, which is having standard deviation, variance, and range. And the third one, we have seen what is expected value and the graphical representations, in which we have again univariate, bivariate, and multivariate, which we have seen some of the univariate plots like bar plot and histogram, and how to create these visualizations in RapidMiner also we have discussed. And then the third and fourth business moments, that is nothing but skewness and kurtosis. And we have also plotted box plot, and we have understood about the normal distribution and also the scatter plot. So these things we have covered in the previous session. So today let's start with the next one, which is data pre-processing. So coming to the data pre-processing, you already know we are working on the raw data. So we have to clean our data. We have performed all the 4 business moments. Now it is the time for data pre-processing or data preparation. So the third one that we have is data preparation. So raw data is your number one enemy. This data preparation is also called as data pre-processing, data wrangling, data cleansing, etc. There are multiple names for this. And then what in this particular module, we are about to cover data cleansing and organizing, and what is typecasting and how to handle the duplicates. And what are the various outlier analysis methods present? And what do you mean by zero variance and near zero variance features? What is discretization and what is encoding? And how to handle the missing values in our data? What is feature selection and what is data scaling and transformation? All these things we are about to discuss in our module. Let's see what is present first. First, coming to the data cleansing and organizing, the raw data will be not properly present. We already know about that. So here, for suppose, see here, there is an example given at the bottom. You can see here the example. So what is this example regarding? What is this example regarding? So first of all, data cleansing. So data cleansing is nothing but whenever we have information like this. For suppose if you observe here, there is an information which is getting recorded in the server log. So imagine this is the information which is getting recorded in the server log. While recording this information, there may be some of the junk included, which is present over here in the red color box. So this is nothing but the junk. Okay, so we don't need junk in our data. While data cleansing, what we do is we will remove that junk and we will present the data. So data cleaning is nothing but removal of unnecessary information from the raw data. So here if you observe, in all the current information present, we remove the junk, which is nothing but data cleaning. And coming to the organizing. Here if you see this data, which is present on the left side, this is not in the proper format. We can call this as unstructured data. What we can call this as? We can call this as unstructured data. So unstructured data is present over here. We are organizing our data. What do you mean by organizing our data? In order to make it meaningful, we have converted it into a proper format, which we can call as structured data. So what did we do? We have created 2 columns. One is date column and second one is text column. We have created these two columns in order to just convert that information in meaningful manner and also in proper format. Here, whatever the unstructured data is there, we are organizing that data into structured format. So now you can easily understand on this particular date, this is the information present. On this particular date and time, this is the information present. This is nothing but the first thing present, which is data cleansing and organizing. What is data cleansing and organizing? Whenever we are recording or whenever the information is getting recorded in the server logs, there the junk may also get present in the data. So we are removing that junk and we are cleaning that data. While coming to the organizing, we have unstructured data which is not properly present. We are organizing that into proper format, which is structured format. And what is present next? Let's see. So the next one that we have is typecasting and handling the duplicates. So what is typecasting first of all? What is typecasting? Typecasting is nothing but converting one data type into another data type. What is typecasting? Typecasting is nothing but we are converting one data type into another data type. We can call it as converting one data type, or we can also call it as converting wrong format into correct format. Converting data type, one data type into another data type, or we can also say that we are converting the wrong form into right form. So what is one data type into another data type means? So we will see the discretization and encoding also. That is also a form of typecasting only, which is we will convert numbers into categories and categories into numbers. So here, typecasting is basically nothing but we are converting one data type into another data type. And what do you mean by duplicates? You already know the word duplicates. When we are having raw data, you may have the data which is exactly same, which means the row which is having the same information will be present in another row as well. First of all, let's talk about typecasting. So typecasting is also called as, what is it is also called as? It is also called as type conversion, type coercion, and type juggling. Typecasting is nothing but converting one data type into another data type. In here, it is also called as type conversion, type coercion, and type juggling. Okay, we can say that as we can convert or we are converting the wrong form into right form. That is nothing but typecasting. We will see how to do this in RapidMiner as well. Now, the next one that we have is handling the duplicates. So what is handling the duplicates? What do you mean by duplicates and how should we handle that? For suppose, imagine we have a data present within which we have information like I'll write my name itself. So I got few records. So this is first name. So what is that present is I have an account called a savings account. Based on that account, I have spent some, maybe I've spent 500 rupees or 5,000. So I've spent 5,000 using my savings account. First, suppose I am recording this, or there is one more record, which is basically of the same person, but the way it is present may be different. Okay, here I have got my full name. Maybe I have a credit card. I've used my credit card and I've spent maybe 10,000. So what is happening here? I have multiple records which are belonging to the same person. We can call this as duplicates if we know whether it is the same person or not. And what are the ways to handle those duplicates? There are multiple ways present. For suppose in this particular scenario, if we observe, how can I understand how much totally I spent using both savings account and credit card? If I remove this, I don't get this information. So I can't remove in this case. So what I do is I will just handle this by adding, which is 15,000. By adding the duplicates, what did I understand? I spent totally 15,000 amount. So this is one way of handling the duplicates. What is the other way? Okay, I told this is the one way. What is the other way then? There are other ways as well present. For suppose, imagine you have an output variable and multiple input variables. We'll talk about output and input variables when we are discussing about supervised and unsupervised learning. For now, understand the concept. So here there are output and input variables, and I'm telling like an input variable is maybe name of the person. I'll take A, B. Okay, these are the names of the persons and so on. And maybe the second input variable may be the gender. Maybe he's male, she's female, male, and so on. And the third input variable may be the salary. Maybe he's having 50,000. He's having 60,000. Sorry, she's having 60,000. And he's having 35,000. And so on. So we are having these input variables. Based on these input variables, I have got an output variable whether the person will churn or not. Okay, so here observe, so NA, or I will write here as churn. So here there are no duplicates. For suppose if I got the information, or if I got another record like this, so again M and again 50,000. If I got the same record which is already there, then this is a duplicate. So when we are passing this information to a machine learning algorithm, so what it does is, based on the records present, based on the input and output variables, it will understand the patterns or trends. Based on the patterns, it will just understand, okay, if the person is male and if he is having the salary of 50,000, he may churn. And if I am giving the same information again to the algorithm, it is of no use. So in such cases, we can go for deleting the duplicates. In such cases, we can go for deleting the duplicates. I will show each one of the steps how to do it in the RapidMiner as well, which is not very problematic. That is just a drag and drop. Single step is present. I'll show it that also. Okay, this is the example where we do the deleting the duplicates option. So let's see what is present in the slide. So here, handling the duplicates, first way is adding, which I told you the example. And second one is, we can remove the duplicate rows or we can remove the duplicate columns. So just like I've told, you can go for the duplicate columns as well as the duplicate rows. Let's see what is the example present over here. So here is an example given, which is having the input variables as well as an output variable. So this is an input variable x1, x2, x3, x4, and based on this, I am getting the output variable. So here, see, here the loan status is default if the person is having the age 33 and if he's a male and the income is 10,000 and he's a graduate. As I told before, if I am sending data, input and output variables to my machine learning algorithm, it will just understand the patterns. So already this was learned. Why do I have to send again the same data? That is of no use. In such cases, I can go for removing the duplicate rows. In such cases, I can go for removing the duplicate rows. And also at the same time, if you have the columns, like what? For suppose, maybe I can take an example here. Just a second. Okay, I will tell you the example here. So we have seen removing the duplicates, which is present in the form of rows. Now, let me tell you an example. When do you go for removing the duplicates in the form of columns? First, suppose if you have two columns present. One is SAT score and second one is maybe high school scores. Okay, two columns are there. One is SAT exam scores and second one is high school scores. You can take any example. I'm telling you an example. So here there are two columns present. Now, based on the scores, I have got few records over here. I've got records over here and also I've got records over here. Now what is it? I want to understand whether these two are having the exact same values or not. For that, what we do is we will understand or we will perform correlation between two columns. We will perform correlation between these two columns, and if the correlation is very high, which means the scores which are present in the SAT are almost same or more or less same to the high school scores. That is nothing but correlation high. So when more or less if both are same, why do I need both columns? One column is enough for my prediction process or anything, right? So in such concept, I will delete the duplicate column. So in such concept, I will delete the duplicate column. So in this example, I have two columns present. One is SAT scores and second one is high school scores. In this particular example, when I just found that the correlation between these two columns is very high, which indicates the values present in the SAT column are more or less same to the high school scores column. So if the values are almost same, then I don't have the need to have two columns. So in such cases, I'll go for removing the duplicate columns. So I've told you before the example of removing the duplicate rows. This is removing duplicate columns. That is nothing but typecasting and also handling the duplicates. What is it? What we have discussed up to now? First of all, we have data cleaning. First of all, we have data cleaning. Data cleaning is nothing but whatever the junk that is getting recorded, we are eliminating that. And the second one that we have is data organizing. So whatever the data that is not properly present in particular format, which is unstructured data, we are converting it into structured data by creating meaningful columns and just getting the data into that columns. That is nothing but data organizing. And then we have typecasting. Typecasting is nothing but we are converting one data type into another data type. I'll show you how to do it in RapidMiner now. So here it is also called as type conversion, type coercion, and also the last one that we have discussed is handling the duplicates. So you already know the duplicates is nothing but if all the columns are having the same values in every record, then those records are considered as duplicates. So there are multiple ways to handle them. One is we can add the duplicates to get the meaningful information. And second one, we can delete the duplicate rows, or we can delete the duplicate columns. Any one of that which makes sense, you can prefer. So this is what we have discussed up to now. Let's see how to do the typecasting and how to just work on handling the duplicates in RapidMiner Studio. So let me open the application that we have created before. We have discussed this in previous session about the interface and what are the basic things that we can do in the RapidMiner Studio. So if you have missed all of those, you can watch the previous sessions. So now let me open my RapidMiner Studio and I will show it to you, the typecasting and also handling the duplicates, how to do it in RapidMiner Studio. Just give it a second. Okay, here's our RapidMiner Studio interface. So before moving on, I'm going to create a blank process. I'm going to show it to you with the help of a blank process. Now, in order to work with the typecasting, what are the operators present? If you see here, I will just type here. So see, so if you want to convert the numerical into binomial, you have this operator. If you want to convert numerical into polynomial, you have this operator. So these are all the operators that you can use if you want to convert one data type into another data type. So these are all the operators that you can see on the left-hand side. So by using this operator, simply you can drag and drop and you can use this in order to convert one column into another column data type. So I will show you one example for this as well. So let me just connect with the data first, then we can observe these operators. So what I do is, maybe I will connect with sample superstore, or I can connect with any values, or just give it a second. So I have this session which was already present in my previous session, which I have loaded. I'm taking sample superstore here. I'm taking sample superstore. Now I will check out how many records and columns are there. Just connect your output port to the response port and execute this process. Once you execute it, you can see at the bottom, the example set, example, special attributes, and regular attributes. So what are these namings? What are the namings that you can see here? So whatever the data set that you're using, the data set is called as an example set. Example set here is nothing but a data set. And then examples are nothing but the records, which are rows, and attributes is nothing but columns. These are the namings present in RapidMiner Studio. Okay, I got my data. Now I want to show you how to convert one data type into another data type. So before moving on to that, I want to convert maybe I want to convert quantity which is present in numbers into polynomial or binomial, which is categorical data. So what I do is, instead of working with all the records or all the columns, I will work with only that specific column. So in order to work with that specific column, you can use the operator called as select attributes. So select attributes, always remember you have to make the connection between different operators, then only the process will get executed. So here, select attributes, there are parameters on the right hand side. You have to just adjust, or you have to make customizations to your operators using these parameters. So I want to include only one. What is that one? Which is quantity. Maybe you can take sales or profit, anything is fine. So I'm taking quantity here. When I execute this process, instead of 21 attributes that I have, I will get only one, which is quantity. Okay. Now I've selected whatever the column that I want. Now what I want to convert this numerical into binomial. See here, there are multiple operators present. You can take any of it. I'm converting numerical into binomial. And you have to make the connection. Remember that if you want to customize this operator, you can go for parameters. So what do you want to make it? So I have numerical value present and I want to convert this into binomial, and I will just give the connection to the response port and I'll execute. I'm not changing any parameters. Let's see what is happening. So binomial, it is taking true as well as false. So how you are getting true and false based on what? Based on this minimum and maximum. So here, if you observe, so what I do is I'll remove this operator and I'll execute it again and I'll see. So here I'll go to statistics and observe the minimum is 1 and maximum is 14. So what do you want to convert? Like for suppose if you are having two categories, within one category, how much range you want? Within another one, how much range you want? So 1 and 14 are the maximum values present. Now I will use this operator. Now, whatever the values which are satisfying this particular range will be true, otherwise it will be false. So the minimum should be 10 and the maximum should be 14. So as I've seen, the minimum is 1 to 14. Here I've taken, what is that I've taken? 10 and 14. And I'll execute this process. Now see, you got true as well as false if you observe. So if you want to check whether you got true, false, you got it or not, you can see here, false is present. And also, you can check it out, true and false, here also false is present. So false is there if it is not satisfying your condition. Okay, this is how you can convert one data type into another data type in RapidMiner Studio. So this is nothing but typecasting. Depending upon your requirement, you will convert. You will not convert all the columns into other data types. That is not necessary. Whichever the columns that you want to make sense or you want to give more information based on the analysis process, you can go for this typecasting. And the second one that we have is handling the duplicates. So in order to handle the duplicates, we should have a data set which is having duplicates. So maybe I have one, I will show it to you. So I will just use, that is the Excel file. So I'm using read Excel operator. So whatever the file that I have, which is having the duplicates, is an Excel file. So I'm using the read Excel operator in order to connect with that data. So I'm double clicking on this one. After this, I have to select what is the data type. Sorry, what is the data set? So my data set name, I have named it as duplicate records data. So I'll show it to you what is present. So I've just taken few records, and if you observe, there are duplicates present. 3 and 4 are exact duplicates. And also if you observe 7 and 9, these are also duplicates. So I have a small data set, which I named it as duplicate records data, which is having duplicate values, and how to handle these duplicates in RapidMiner. I'm not changing anything. If you want to change anything, there are no missing values in this data set. If you want to replace it with errors, you can check this box, but I'm not checking on anything. If you are getting any warnings, whether the data type is not properly present and something like that, you can see at the bottom. So here you can see there is no problem regarding my data set. I will click on finish. Once I click on finish, I got my data imported. Now I will just connect my output port to the response port and I will execute this process. Once I execute this process, you see what is the data present. There are total 11 records and 4 columns. Now what I do? I have to handle the duplicates. So how to handle the duplicates? You have the direct operator, which is, we have the direct operator, which is remove duplicates. So see, there is an operator called as remove duplicates in RapidMiner Studio, which can be used to remove it. So remember, there are totally 11 records and 4 columns. I will just take this operator into the process and I will make the connection between the two operators. So now you can just change it here based on which column you want. You can keep it, but based on all columns, I want to check this duplicates and I want to remove them. So I'm just connecting to the response port and executing the process. Now, if you see here at the bottom, there are now only 9 records present. There are only 9 records present. The rest of the 2 are duplicates. The rest of the 2 are duplicates. So if you want to see the original data as well as this one, you can go for the operator called as multiply. You can explore all the operators. I told you how to get an understanding of every operator. So go to design. I will remove this one and I'll execute the process. And I will see there are total 11 records. I will go to design. Instead of this, I will use multiply. So see here, I am using the operator multiply and I will show it to you what is the output. So multiply, and after that, I will just use the operator which is remove duplicates. I will tell you what is the purpose of multiply. So remove duplicates from this one, from this multiply operator, I'm making the connection to the remove duplicates, and this port, I'm connecting it to the response port. So what did I do? I have my input data present over here, which is duplicates data. I'm connecting it to the multiply operator and I am connecting this to the response port. This is the original data. After that, I'm just connecting this second output port of this multiply operator as input to remove duplicates operator. Now let's check it out what happens when I execute this process. So what is happening? This is the original data set and this is the remove duplicates operator. After that, executing the process. That is how you can use the multiply operator in order to understand the difference between the original data set and what happened after using this operator. So what did I do? Everybody see? So I will just make it distant so that you can understand clearly. So I have got some data set, random data set with 11 records totally, which is having duplicates. So within that data set, I want to see whether the duplicates are getting removed or not. I'm not understanding correctly. So I want to compare the original data set with the removed duplicate, the duplicates removed data set. So I want to make the comparison. So here, what did I do? I've used multiply operator. So in order to get an understanding of all the operators, what did I tell you? So right click on the operator and click on show operator information. So what is this purpose? So this operator creates copies of an object, which is nothing but a data set. So here, this is the original one and this is the remove duplicates one. Okay, here I'm not applying anything. Here, if I apply any operator, the outputs will be again different. Okay, so this is how you can handle the duplicates in RapidMiner Studio. First, what I have shown, how to convert one data type into another data type, which is typecasting. And second one is how to handle the duplicates in RapidMiner. So up to now, we have discussed, and let's see what is present in the slides. Before moving on to the next one, I'll give you 2 minutes. Just work on this. I'll move on to the next one. Yeah, in order to make you understand how this is happening, I've created some random data set. You can create your own. I have written something in before when we are explaining the slides, right? So when I'm having 2 records of same information, that is nothing but a duplicate. So how to remove that? When we come to this RapidMiner Studio interface, I've shown you with the sample data. So rest of the data set, all of these are present in your LMS. If you are joining from the LMS, I'm just talking about the data sets which we mostly use. The sample superstore, iris dataset, ethnic diversity. These are the datasets which I'm mostly using in the sessions. Okay, I'll give you 2 minutes. I'll wait for 2 minutes and I will start talking about the next one. You did not get the RapidMiner access in your LMS. I don't know about the LMS access. Maybe I have to talk to the team. And the data sets are present in the previous modules that you have done, like in Python. What is that? Maybe in Power BI, you have got these data sets, or in Python also, I guess. Okay, that is about typecasting and remove and handling the duplicates. Now let's talk about the next one. Okay, we will see what is present next. The next we have the most important one, which is outlier analysis. So what is outlier analysis? What do you mean by an outlier? You already know what is an outlier. We have talked about this before. Outlier is nothing but an extreme value. So when we are having a column, within that column, if we have, for suppose we have explained this when we are talking about median, mean, and so on. So 5, 6, 7, 10. I have 1 lakh. So out of this column, the values present in this column, I can treat this as an outlier because this is extremely large when compared with the other values. So it need not to be always extremely large. If it is extremely small also, we will treat it as an outlier. Like what? For suppose 2, 50,000, 70,000, 1 lakh, 2 lakhs. So this is my data. So out of all these values, this is extremely small. This can be also considered as an outlier. So an outlier is basically an extreme value that may be extremely high or extremely less, extremely small. Anything is fine. So how to just analyze the outliers and how to treat those outliers? We will see what is present. So as we have discussed before, when we are talking about outliers, always we use box plot. So box plot is one way of identifying the outliers. First of all, we have outlier analysis or treatment. So within that, we have a technique called as 3R technique. So what is 3R technique? What do you mean by 3R technique? Whenever we are finding an outlier in the data, do we have to delete them every time? Every time the same process? No, it is based on, in this 3R technique, there are 3Rs present. The first R stands for rectify, and the second one stands for retain, and the third one is remove. So there are few causes or few reasons when you have to go for which type of technique, like rectify, retain, or remove. So when we come to here, for suppose, okay, let's see that there is an example provided here. Okay, here, if you observe this example here, there are two columns present. One is month and second one is sales. So out of these two columns, so there is month January, which is having 1,000 sales, and February 890, and so on. These are the sales present. If you observe, when we compare the sales values, this $1 million is extremely large. So what we talked about an outlier, if it is extremely large or extremely small, we can consider that as an outlier. Okay, fine. Now I have outlier. So what I have to do, whether do I have to rectify it or retain it or remove it? How can I do this? How can I understand what to do? So for this, you have to first understand the reason why you are having such large values. You have to understand the reason why you are having such large values. So for suppose, you have asked your salesperson. Okay, I'm telling you one cause. So you have asked your salesperson, like, why did I get an exceptionally large value in the month of May? Why did I get it? So he told the reason like, okay, he just copied and pasted the data by mistakenly. There are 2 additional zeros coming over here. That is the reason we have large value in our data set. So if you are having such type of reasons, you have to go for rectify. You have to go for rectify. What is it? For suppose the reason for this particular outlier in our data set is just by mistake. That is not voluntarily done. So that is when you have to go for rectify. And what about the retain? What about remove? For suppose if he told the reason like because of some innovation technique that we have used in the month of May, we got highly exceptional sales. So when we have like for suppose what we can say, okay, when we have the chances of getting such extreme values in the further months also, when we have the chances of getting such high values in the further or future data also, then we have to go for retaining those outliers. What is it? When we are having the chances of getting those extreme values in the future data, in such type of scenarios, you have to go for retaining the outliers. And what is the third one? The third one that we have is remove. When do you go for removing the outliers? When it is opposite of this retain. When you don't have the chance of having this extreme values to be present in your future data. This is by mistake. This is not like a, what I can say. This is not going to appear in future in my data. In such cases, I should go for removing those outliers. That is nothing but 3R technique. So 3R technique, 3R, which means 1R stands for rectify, and second R stands for retain, and third one stands for remove. So this is how you have to go for whether you want to rectify the outlier or you have to remove the outlier or retain the outlier. Okay, now let's see what is present next. So the next one that we have is Vincerization. I think you already know about this Vincerization. So what is Vincerization? So in Vincerization, we will take some percentile. So what is percentile? We have already discussed in a box plot. We have a box plot present. Within this box plot, you already know this is called as minimum. This is called as Q1. This is called as Q3. And this is called as maximum value. Okay, so here you have already known this first quartile is also called as 25th percentile, and it is also called as 75th percentile. These namings we have also seen. So in Vincerization, we will take some value, which is nothing but, for suppose I will take 5th percentile, 5%, or I will take it as 5th percentile. So what happens when I take the value as 5th percentile in Vincerization? What happens? So here in the box plot, so whatever the values which are less than 5th percentile, which are greater than 95th percentile, okay, just a second. So whatever the values which are less than 5th percentile will be replaced with 5th percentile. So in Vincerization technique, whatever the values which are less than 5th percentile in the box plot are replaced with the 5th percentile, and whatever the values which are above the maximum, that is 95th percentile, will be replaced with the 95th percentile. That is how there is another way of treating the outliers called as Vincerization. So the one technique that we have discussed for the first is 3R technique, which is rectify, retain, and remove. And the second technique that we have is Vincerization, within which we will take a value of percentile. Based on that value, we will replace the outliers. You can take 90 percentile also. Anything is fine. Anything is fine. So basically, we will use 5th percentile. You can go for anything you want. So this is how we will use another treatment technique called as Vincerization technique. And what is the next one present? The next one that we have is trimming. So trimming is an extension of Vincerization. Here also, we will take some value which is called as alpha value. For suppose if I take the alpha value as 5%. So this is an extension of Vincerization. Here what happens? Whatever the values which are less than 5th percentile or 5%, they are trimmed off, which is called as remove. We are removing those values. And whichever the values which are greater than 95th percentile, they are also removed. So in Vincerization, we are replacing those values with the percentiles, whereas in trimming, we are trimming those data. That is the difference between Vincerization and trimming. So Vincerization Vincerization is one technique present to treat the outliers, in which we will replace the values which are less than 5th percentile with the 5th percentile, and the values which are above 95th percentile are replaced with 95th percentile. Coming to the next one, trimming. Trimming is an extension of Vincerization. In trimming, we are not replacing any outliers. We are just trimming those data. Which values we are trimming? We will take a value called as alpha value here. If alpha, I taken it as 5%, 5% or 5 percentile. If the values is less than 5th percentile, then I will trim those data. If they are greater than 95th percentile, I will trim those data. This is nothing but the next technique present, which is called as trimming. So I will show how to treat the outliers, how to handle your outliers in RapidMiner Studio as well later. So we will see what is present next. The next one that we have is the namings or the words present. One is masking and second one is swamping. So what is masking and what is swamping? So understand here. So there is a word or name called as masking. So what is masking? So outliers exist, but we fail to detect those. What is it? We have outliers, but we are failing to detect them. In our data, we are having the outliers, but we are not identifying them as outliers. So this is called as false negative. This may happen for a lot of reasons, like because of using the wrong technology, or a lot because of we are not analyzing the data properly. There may be a lot of reasons in order to get this masking. So masking is a word which we use whenever the outliers are present in our data, but we are failing to detect those. That's when we will use the word masking. And the next word that we have is swamping over here. Swamping is nothing but detecting noun outliers as outliers. There are few data points which are not outliers, but because of some reasons, we are detecting those as outliers. That is called as swamping. This is also called as false positive. This may also happen because of a lot of reasons, like because of oversight or because of lack of knowledge. We are detecting the non-outliers are outliers. So these are the various reasons present in order to use the words masking and swamping. So outlier analysis or treatment, we have the first one, which is 3R technique. So 3R technique, rectify, retain, and remove. If we have or if we understand that it is by mistakenly entered because of some copy paste issue, you have to go for rectify. If we understood that that outlier I got in my data is going to repeat in my future data as well, then I'll go for retain. If I have understood that the outlier that I got will not repeat again in my future data, then I'll go for remove. The next one that I have is Vincerization. Vincerization is one of the other treatment method present for the outlier analysis treatment. So Vincerization, in this, we will take some percentile value. Based on that, we will replace the outliers or the extreme values. And in trimming, trimming is an extension of Vincerization. But in trimming, we are not replacing any values. We are trimming the data based on the alpha value. And the two namings that we have discussed, one is masking and second one is swamping. So these are the basics. And what is present next? The next one that we have is standard deviation approach. We are identifying the outliers using standard deviation approach, which we have seen in the previous session. For suppose if I take the standard deviation as plus or minus 3 standard deviation. If I take my standard deviation as plus or minus 3 standard deviation, like x bar plus or minus 3 standard deviation. So which means what? So here this is minus 3 standard deviation. Whatever the values which are less than minus 3 standard deviation and whatever the values which are greater than plus 3 standard deviation, these are identified as outliers. When we are using the standard deviation approach to identify the outliers, for suppose if I take the standard deviation as plus or minus 3, then whatever the outliers, whatever the values which are present or which are less than minus 3 standard deviation, and whichever the values which are greater than plus 3 standard deviation are treated as outliers. If I take x x bar plus or minus 2 standard deviation for suppose, so whatever the values which are less than minus 2 standard deviation from here to here and which are greater than plus 2 standard deviation, these are considered as outliers. This is nothing but identifying the outliers using standard deviation approach. And what is next? There is one more thing, which is identifying the outliers using IQR approach, which we have already seen when we talked about the box plot. So here, if we observe minimum Q1, Q3, maximum, whatever the values which are less than Q1 minus 1.5 into IQR, the values which are less than Q1 minus 1.5 into IQR, the values which are greater than Q3 plus 1.5 into IQR are considered as suspected outliers. We will call them as suspected outliers. And the next one also we have understood, whatever the values which are less than Q1 minus 3 into IQR, and whatever the values which are above Q3 plus 3 into IQR, those are called as outliers. So this is how we can identify the outliers using IQR approach, interquartile range approach, which we can see in a box plot. So identifying the outliers using standard deviation approach and identifying the outliers using IQR approach. Okay, now let's see what is present next. So identifying the outliers using automatic outlier detection, which we will see in the predictive modeling. This we will discuss later. Okay, so now let's see how to just handle the outliers in RapidMiner Studio. So we are discussing about how to do it in here, the theory, and how to use that in RapidMiner Studio. Okay, so now let me open that one. So let me go back to this RapidMiner Studio over here. So I will delete the process, whatever I have taken. How to delete it? There are multiple operators present. I'll just draw a box and I'll delete it. Click on delete in the keyboard. Okay, so now here I'm going to use the default or the inbuilt data set Titanic over here. So where can I see the inbuilt data set? Everybody, I have told you this before. So there are some inbuilt data sources present in RapidMiner that we can see in the repository panel. In the repository panel, within the samples folder, I got a subfolder called as data. I got a data subfolder. And within that subfolder, I have all the inbuilt data sources or the default data sources. Okay, within which I'm going to use one which is Titanic. I'm going to use the default data source Titanic in this case. So where is that present? I'll show it to you. See, so here in this repository panel, under samples folder, I have data subfolder. Within this, I got Titanic. When I scroll down, I can see the Titanic over here. So in order to use this, I simply have to drag and drop it into the process. This is the process. I dragged and dropped it. So now in order to execute the process, I told you, you always have to connect the output port to the response port. Connect it and execute this process. Once you execute this process, you can see there are totally 1,309 records. Okay, there are totally 1,309 records and 12 columns. Now what I have to do? I have to detect the outliers. How can I detect the outliers in RapidMiner Studio? You have to understand the operators, using what operators that you have to use. You have to get the idea for that. Now, I don't want to find out the outliers for all the columns. So I want to select my columns. So I will simply go for select attributes operator. I don't want to detect the outliers for all columns. So instead, I'll go for selecting few columns using select attributes operator. So connect the Titanic output port to the input as connect the output port of retrieve Titanic operator as input to the select attributes. If you want to customize, you can do it in the parameters. Click on the select attributes operator, and on the right side, you got the parameters. Here, I want to include a subset, means few columns. If you want to include all, you can click on all. If you want to include only one, you can click on one. But I want to include a subset of columns, which means a group of columns, few columns. So I'll click on select attributes. Out of all the columns present, I will choose maybe age, maybe name of parents or children, name of siblings, passenger class, passenger fare, port of embarkation, maybe ticket number. Okay, these are enough. So I have selected few columns. So whatever the columns that are present on the right side are the ones that I have selected. I am just I don't want these columns to identify outliers in these. So I'm going for these columns and click on apply. Okay. So as I told before, if you want to customize your your operators, you can do it in parameters option present on the right hand side. So I've selected few columns. You can use whatever the columns that you want. So here, as I told before, the customization is nothing but for every operator, you will have the parameters on the right hand side. So for every operator, even for the retrieve Titanic, for select attributes, any operator will have parameters. So what is the use of parameters? Parameters use is to customize your operator according to your requirement. Here, there is an operator called as select attributes. With the help of this operator, I'm going to select few columns out of Titanic. What I want to do, so here, by using this operator called as select attributes, I'm going to select few columns that I want. I don't want all the columns. I want only few columns to just work on the outlier detection. So I'm selecting only few columns using the select attributes. How can I customize this? With the help of parameters on the right hand side. This is how you can customize your operators. Within this, what did I do? Under this attribute filter type, I have selected subset, which means I want to select few columns. If you want only one column, you can go for single. If you want all, you can go for all. Now, after that, I have gone for the select attributes option present here. Click on it, where double click on the columns that you want for your analysis process. I've selected these columns, which are present on the right side. Okay, I have these columns which are present on the right side. And after that, click on apply. Now, if you want to execute this process, you always have to connect this port to the response port. After making the connection only, you have to execute the process. The connection is done. I will just delete the drawings and I will execute this process. Once I execute this, how many records are there? Only 7. If you want to just make the comparison between the original data and this data, then what you have to do? You have to use the operator which is called as multiply. So multiply will produce the copies of your original data. So see, I will just connect this one and I will make the connection to the response port and another output port as input to the select attributes. Now I will execute this. Now you can see the original data as well as the select attributes data. So see, this is the original data which is having 1,309 records and 12 columns. Whereas when I have used the attributes, I've selected only few. So now I got only 7 columns out of 12. Okay, fine. This is done. Now what about next step? Okay, I have selected whatever the columns that I want. Now what should I do next? I have to normalize my data. See here what I'm doing. So I will talk about the normalization in the coming session. For now, understand the flow. So I'm using another operator, which is normalize. So I'll just take it here. Okay, I'm using the next one, which is normalize. So I'm not checking anything. What I do is I'll connect the select attributes output as input to the normalize. And in the normalize, I'm not clicking on anything. Okay, I'm just selecting over here, maybe range. You can select whatever you want. Okay, I'm just clicking on Z only. I'm not changing anything. Okay, normalize is fine. Now what? Now you have to use the operator that is detect the outliers by distance. You have multiple ways of detecting the outliers through distance, through density, through LOF or through COF. So what are these options? What do you mean by distance based? What do you mean by density based? All of these things. We will talk about the distance in clear later, but I'll give you like a basic understanding. So what is this one? First of all, you have the outlier, which is detect outlier distances. So this is basically a distance-based method which identify the outliers based on their distances from other data points in the data set. For suppose there is a data set which is having different data points. Now we will just calculate the distance from one data point to the others and one to the others. So by calculating the distance, we are able to identify the outlier which is very far. That is nothing but distance-based method, which is detect outlier through distance. This is what we basically use in RapidMiner Studio. And coming to the second one, you have densities. So what is density-based method? So here density-based method, it identifies the outliers based on the region of low data density in the data set. So it is based on some parameters which we will see later. So LOF and COF are the other operators present. LOF stands for local outlier factor. LOF stands for local outlier factor. If you want to get an understanding of how to use those operators, what is the operator description, you can right click on it and click on show operator info, where you can see the description of every operator present. So LOF stands for local outlier factor, and COF stands for connectivity based outlier factor. So these are the different operators present in order to handle or detect the outliers. So the basically used one is detect outliers through distances. So COF is connectivity based outlier factor. Okay, so as I told, the most basic used one is this one. So I'm going to use this in my process. So I will take this distances here. Okay, I'm taking the distance over here. Now, if you want to execute the process, you have to make the connection. Connection is mandatory. So what I do, I will just make the connection from normalize to detect outliers. Normalize to detect outliers. So I'm not changing anything here also. After that, whether I'm detecting the outliers, I will get as a true or false. I'll tell you what is true or false. First, let me use the operator, that is filtered examples. So filtered examples operator is one more operator present. Let me just take it here. Okay, in order to show you properly, I'm just adjusting this one. So I'm just taking detect outlier as input to the filter examples. So in filter examples, I want to customize this one. So what do I want to customize here? So here, see, when I click on filter examples, I got parameters on the right hand side where I have add filters option. Click on add filters. After clicking on add filters, in the first drop down, you can see an additional one coming, which is outlier, because we have used the operator, which is detect outlier based on distance. So click on outlier, and outlier equals to, here you can see a magic brush symbol. Click on this one and check whether you want false or true. So what is outlier false option and what is outlier true option? What are these two options present? So when you take outlier false, when you select the false option, what happens here means the outliers will not be filtered or removed from the data set. So what can I say? When I take outliers, within that I have two options. One is false and second one is true. When I take it as false, the outliers are not filtered or not removed from the data set. When I take true, the outliers are removed and rest of the data can be shown in the data set. So I'll show you how. Let me erase this one. So local outlier factor and connectivity based outlier factor. Okay. So I will select first of all false and I will show the difference. So I'm selecting false, outlier equals to false and click on OK. Okay, fine. I got this one. Now in order to get the output, you have to connect this to the response port and click on execute button or play button. So this is taking some time. So when I do this, it will just show me the outlier. See here, this is the original data, which is having 12 columns totally. So this is the original data having 12 columns. So see, 12 columns are there and 1309 records are there. And here also 1299 records are there. And 7 columns, 7 regular attributes are there and one special attribute, that is outlier, which got added now. So it is showing false. See here, false. Now, if I take true, I'll go back to design. I'll click on filtered example, add filters, and whatever that are outliers will be shown when I'm taking true. So see here, true and okay. So when I execute the process, the outliers can be seen. That is nothing but false and true. Just give it a second, it is processing. So here you can see what are all the outliers present in our data set, which is totally 10 years in RapidMiner Studio. So what is it? First of all, I have used the Titanic data set, which is present in the samples folder, which is an inbuilt one. And I want to understand the difference between the original data and after doing the process, what is the data? So for that purpose, I am using the operator multiply. So multiply will create a copy for my data set. For one copy, I'm getting the response, which is original. And for another copy, I am just doing the further process, which is Out of all the 12 columns, I've selected 7 columns using select attributes. And I'm normalizing the data. I'll tell you the normalizing later. Okay, what is normalization? What is standardization? We will talk about that in later session. And after normalizing the data, I'm going to detect the outliers. We have different operators present over here. 4 operators basically. Out of those, we are about to use mostly, which is detect outliers through distance. After that, you have to filter out whether you want to show only the outliers which are present or the normal data. False is normal data and true is outliers. So you can use the option whatever you want in the parameters, which is nothing but the customization. And if you want to execute the process, just make the connection from the filter examples operators to the response port. After just doing the process, execute it and you will get the output. That is how is you detect the outliers in RapidMiner Studio. Okay, up to now we have discussed the typecasting, how to change the data type. And also, I have shown you the operator called as remove duplicates if you have any duplicates present in your data set. And the third one that we have here is outlier analysis, how to detect your outliers in RapidMiner Studio. So I'll give you a few minutes. You can just work on this one because Titanic is already available in your inbuilt data sources itself in RapidMiner Studio. There is no need to download or bring it from your local machine. I'll give you a few minutes. You can work on it. After 2 minutes, I'll start talking about the next topic. So everybody, in multiply, I did not customize any parameter. In select attributes only, I have created a subset, which means I've selected few columns. You can select whatever the columns that you want. Okay, any column is fine. That is nothing but we are detecting the outliers. So any columns up to your choice, you can choose it. Okay, out of 12 columns, I've chosen only 7 columns. And later on, I did not customize this operator. But here also, I did not customize anything. And here, in the filter examples, I have just created the filter, which is whatever the outliers are present, which is true, I want to show them in my output. So I've created this filter or customization in filter examples operator, and I executed the process. And before executing the process, you always have to check your connections, whether all the operators are connected properly and other at last, whether they are connected to the response port or not. You have to check all those things before executing the process. After executing it, this is my result. This is my original data. And this is my data which I've got, which is nothing but an outlier. Okay. So this is how you can detect the outliers in RapidMiner Studio. Let's go back to the sheet level and see slides and see what is present in the slides. The next one that we have is zero variance features. So what is zero variance features? What do you mean by zero variance features? So you already know features are nothing but the columns. So variables or features, anything is fine. That is nothing but the columns. So what do you mean by zero and near zero? What do you mean by zero and near zero? For suppose, imagine we are going to predict a model based on what? Based on input and output variables. Like what? For suppose there are various employees present. So for various employees, I'm noting down their age, which is one input variable. And then I'm noting down their gender. What are their what is the gender of particular employee, which is another input variable. And I'm just noting down their income. Income comes under another input variable. Now, I have, based on this, I can just create one output variable y. Sorry, I can create an output variable y, which is belonging to whether an employee will resign or not, will attreat or not. So based on that, I'm creating this report or I'm creating this data set. For suppose this is an example data set. So here, maybe I will take here. There is an employee called like a 32, 35, 40, and male, male, 36, male, and so on, so on. And income, I'm just writing some random numbers, 20K, 35K, 40K, and so on. So if a person is of age 32, and if he's male, and if he's having the income 20K, I'll write it as he will resign, which means he will attreat, and he will not attreat, and he will not resign, or he will not resign. So when I am sending this for prediction process, which is I'm going to build a predictive model. What I'm going to predict whether an employee is going to resign or not. So we will talk about this predictive modeling also in detail later, but for now, this is just an example, okay? So here I'm going to predict based on the data available whether whether an employee will resign or not based on the other features or other columns. So based on this predictive model, I will understand the patterns between the output variable and input variables. Based on this predictive model, I can understand the patterns between output variable and input variable. So here the output variable is this one and rest of all are inputs. Okay, fine. So this is how predictive modeling works. Now what happens? If you observe here, if I am sending this particular data set for predictive modeling to a machine learning algorithm, as I talked about before, it will understand the patterns of all the columns present in that particular data set. But if you observe this particular data set, which is having 4 columns, there is a specific column which is gender column. So why am I specifically talking about gender? Because all the values which are present in this column are belonging to one particular category, which is male. There is no differentiation present between these values present in this column gender. So when we are having all values same in particular column, all values are same in a column, then we can call it as zero variance features or zero variance columns. Okay, so whichever the column is having all the values same, we can remove that column because that is not necessary for prediction process. Without this also, I can predict based on the available data. So if the person is 32 and having 20K salary, he may resign. So this is not necessary because this is not making any sense, which is having all the records same value. But this may not be the case all the time. You may have another concept called as near zero variance features. Not only zero variance, near zero variance features is also present. Let's see what is present in the slide. Okay, so here zero is present and near zero variance feature is also present. So whenever your data, whenever in the data set, in a column, if you are having all the values same, that is called as zero variance features. Then what about near zero? What is near zero then? So near zero is nothing but, okay, just a second. Near zero is nothing but, for suppose there is another column called as gender. Okay, there is one specific column called as gender. And within this, there is male, 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 female, male, male, and so on. So when I analyzed this particular column, I observed male category is maybe 98% and the rest of the 2% is having female category. Out of 100% records, 98% of the records is having male category and rest of the 2 records is having female category. So when we are dealing with a categorical column, here this gender is a categorical column. You already studied about the data types. What is categorical? What is numerical? What is count? We have already seen all those things. So this gender is a categorical column. So when we are working on a categorical column, we will understand this zero variance and near zero variance based on proportion. What is it, everybody? When we are understanding this zero variance and near zero variance features in a categorical column, we always go for proportion. So what is proportion? As I told, when one category is occupying most of the proportion compared with the others, one category, or I can say, one category is occupying more proportion, which means out of 100% in the example that I've given, most of the proportion is occupied by one specific category, male. This comes under near zero variance features. Okay, so when we are working on the categorical column, you can go for the proportion. Then what about a numerical column? What about a numerical column? So when we are about to understand this concept in numerical column, you will go for variance or standard deviation. You already studied about variance and standard deviation before. So this is called as zero variance features or near zero variance features. This will not give any understanding or any sense to the data in order to understand or predict the model based on the data set. So we can simply delete them. When we are based on the categorical column, we can remove them based on proportion. If we are working on the numerical column, we can remove them based on variance. So let's see what is present as an example in the slide. Okay, so here there is a column present that contains a single value, just like I've told before. So there is a column present. You have to identify the columns that contains a single value. In this particular education column, there is only one value, that is graduation. There are no other values. So without any second thought, you can delete this because this is zero variance feature. And next what? Next, what is the next example? So you have to identify the columns with a few unique values. So as we are talking about categorical columns, we are having this proportion. So whichever is having the same value, you have to delete them. And whichever is the column having one category occupying more proportion, you have to delete them. This is in the case of categorical columns. So what about in case of numericals? Let's see. So here see, in case of numerical values, you have to check for the variance. If the variance is less than 1, you can remove that column. What is it? What did we understand up to now? When we are talking about zero variance and near zero variance features, first of all, we have to understand whether that is a categorical column or a numerical column. Okay, if it is a categorical column, what we have to do? We have to identify whether that column is having a single value or it is having one category occupying more proportion. One category more proportion. That is what we have to understand. And then you have the next one, that is numerical column. With the help of numerical column, how can you identify this one? Based on variance. If the variance is 1 or less than 1, you can remove that column, which is called as zero and near zero variance features. This is another pre-processing steps that is present. Let's see what is present in the mind map and we'll move on to the next one. Okay. So let me open the mind map and we will discuss about the data preparation. So here is our data preparation, which we have seen the exploratory data analysis in the previous session. We have seen all of these things. Now we are talking about data preparation or data pre-processing or data wrangling. Multiple namings are there. So within which we have completed typecasting, which is converting one data type into another. And the second one that we have is handling the duplicates, which is getting single source of truth from various entries in one such example. Okay, various entries are there, which is having same value. So you have to handle those duplicates. And outlier analysis or treatment, we have 3R technique. 3R stands for rectify, retain, and remove. Here, and masking is nothing but the outliers exist, but you fail to detect them. And swamping is nothing but we are detecting non-outliers as outliers. And vincerization is nothing but we are using some percentile in order to replace the values. And trimming is we are trimming the data based on alpha value. Trimming is different from vincerization. So this comes under outliers. Fine. Now the next one and the last one that we have discussed up to now is zero and near zero variance features. Coming to this one, So usually we ignore the columns with the same entries throughout, or if majority of the entries are the same, that is nothing but zero and near zero variance features. So all entries of a column called country shows only one particular value, which is USA. So it will not make any sense, or it will not give you much importance for your analysis. Then you can ignore that column, which is called as zero and near zero variance features. Okay, let's see what are others present in the slide. Before moving on to the next topic, let's take a quick 10-minute break and come back. Okay, we have discussed up to zero and near zero variance features, everybody. So let's take a 10-minute break, and after that, we will start discussing about the discretization or binning or grouping. Yeah, you can just directly use the detect outliers also. But normalize means if we have larger values, I'm just normalizing them and I'm using the detect outliers option, which is easy to understand. If not, it will take a lot of time to process. Okay. So we will get back after 10 minutes. I'll be on mute. Okay, everybody. Let's continue with the session. So we have discussed up to zero and near zero variance features. Now let's see discretization. Okay, let me open the slides. So here comes the discretization and encoding. First, let us understand what is discretization and then we'll move on to encoding. So here, discretization is nothing but converting numerical data type to categorical data type. Just like I've shown you before, using the operator numerical to polynomial or binomial in RapidMiner Studio, you can do this, which is nothing but typecasting. So here, why do we do this discretization? What is the need of doing discretization? So when we are working in machine learning algorithms, so some machine learning algorithm will expect you to have your data to be in categorical only. Like decision tree, we'll talk about those in clear later. But because of some decision tree, just like that, machine learning algorithms expects your data to be in categorical. We will convert the numerical columns into categorical columns. Okay, so what? So here we have different types like binarization and binning, and there are different other types also. Before moving on to that, we will see what is discretization with the help of an example. So we are converting numbers into categories, which is called as discretization. And here at the bottom, you can see the examples. In the following example, you can see two columns. One is salary and second one is category. So what is this salary and category? So there is a numerical column present, which is salary, and I am converting this numerical into categorical column. How am I converting? Using discretization. So what is this discretization based on? There are few rules. Let's check it out. Here at the bottom, you can see the rules coming. So there are few rules like the salaries which are less than or equal to $4,000 are coming under the category low. So whatever the salaries that are greater than or equal to 10,000 that are high, and the salary in between will be medium. So based on these rules, we are converting the numerical column into categorical column. So 6,000. 6,000 is in between 4,000 and 10,000. So it is medium. So it is medium. So 8,000 it is also in between 4,000. So it is medium. And 12,000 is about 10,000. So it is high. 2,000 and 3,500 or less than 4,000. So this comes under low. Okay, fine. This comes under low. Now what? So here, if you observe, the numerical column got divided into three different categories. One is medium, second one is high, and third one is low. So what did we do in this example? There is a numerical column present. We are converting that numerical column into categorical column. How am I converting? Based on some rules present? How many categories? Three categories. One is medium, second one is high, third one is low. So these are the three categories present. We are converting this salary column into. Now, there is another one which is called as binarization. Binarization is also another form of discretization, but in here, we will convert a numerical column into only two categories. So here, if you observe, there are three. But instead of three, if I have only two, then that is called as binarization. What is binarization? Binarization is a form of discretization in which we will convert a numerical column into two categories. Let's see what is present. So here, if you see here, this is called as binarization. Why? Because there is only two categories, high and low. So we are converting the salary into two different categories or two categories only. Then that discretization is called as binarization. Okay, what else? What else is there? So the next one that we have, here see, this is called binarization because there are only two categories present. Here also we have few rules. If the salary is less than or equal to 75,000 or 7,500, it is low. Greater than or equal to 75,000, it is high. You can take here or here, anywhere is fine. Okay, this is how we are creating or we are converting a numerical into categorical, which is called as discretization. And apart from the binarization, what else are there? Apart from binarization, what else are there? We have the next one, which is rounding. So what is rounding? For suppose there is a column. There is a column within which maybe, okay. There are values like 1.65, 2.4, 3.3. 1.7, and so on. So there is a column present which is having numbers. So I want to convert this into categorical column. How can I convert? Or how can I just perform rounding? So rounding you already know. Rounding is nothing but you are having either ceiling values or you will have floor values. So what is floor and what is ceiling? So in this current example that I've taken, the ceiling will be like what? It is 1.6, which means 2, 2.4, which means 2, 3.33, 1.7 is again 2, and so on. These are ceiling values, which means value up. Which means what? So if the decimal, after the decimal point, if the value is maybe greater than or equal to 5, then I will round it off to the new number, which is 1.65 will be 2. 2.4, this is not equal to 5 or less than 5. So I will take it as 2. 3.3, this is also not greater than or equal to 5. I'll take it as 3, and so on. So what about the floor values? Floor will be value down, which means 1, 2, 3, 1, and so on. These are the ceiling values. These are the floor values, which comes under rounding. So binarization is nothing but one form of discretization where we convert the numerical data into two categories. And there is one more thing, which is rounding. Rounding may be either floor values or ceiling values. And there is one more thing, which is called as binning. So what is binning? Binning is also similar to this discretization itself. But here, instead of rules, it will create bins. So what is bins? So it will create bins like, there are 3 bins totally in this example. One is medium, one is low, and second one is high. So this is nothing but binning or groups. We are grouping the records which are medium into this bin, and whichever are low are grouped into this bin, and this comes under this bin. This is how we will do the third concept called as binning or grouping. So binning is nothing but instead of writing this here, it will create 3 individual bins, and based on that bins, you will get these values. That is nothing but binning. In binning also, you have again 2 types, fixed width binning and adaptive binning, which means what? So here we are, based on the rules, we are getting this fixed width bin, which means I'm telling I want 3 bins, which means I want 3 different categories like that. But in adaptive binning, we are not telling how many bins that we want. We are leaving that to the algorithm, how many that it will create automatically. It is called as adaptive binning. So binning is of 2 types again, fixed width binning and adaptive binning. Fixed width is nothing but we are telling how many bins that we want, and adaptive binning is nothing but I am not telling any number of bins that I want. I will just leave it to the algorithm and let it decide how many bins that it creates according to the data. So these are the various things present in discretization. So first of all, discretization is nothing but converting numbers or numerical data into categorical data. If we are converting the categories as 2, then that is called as binarization. If we are rounding off the numbers to floor or ceiling, that is called as rounding. And instead of creating or converting as discretization, we can go for binning as well, which is nothing but number of bins. If we tell the number of bins that we want, it is called as fixed width binning. If we don't say the number of bins, if we just leave it to the algorithm, let it create the number of bins according to the data, such type of binning is called as adaptive binning. Okay, up to here, this is fine. So what is there next? What else are there? Okay, this is done. Discretization is done. The next one that we have is encoding. So in order to show this in RapidMiner Studio, I've already told you there are numeric like a number of operators present which converts numbers into categories. So this number into binomial, number into polynomial, these two comes under discretization operators. So I've shown you this one before. You can convert it into polynomial as well. Okay. And the next one that we have is encoding. What is encoding? What is encoding? So encoding is the reverse of discretization. In encoding, we are converting the categorical data into numerical data. So in encoding, we are converting the categorical into numerical. This is also because of some machine learning algorithms only. Certain machine learning algorithms like KNN, regression, all of those will prefer mostly numerical data. So when we are working on such type of machine learning algorithms, you have to convert this. which is nothing but either discretization or encoding depending upon your purpose. So encoding is nothing but converting categorical column into numerical column. So what is the example? Numbers is there, categories is there, categories is converted into numbers, which is called as encoding. Fine. Now, within this, you have again one hot encoding, which is binary encoding, and also various other types like label and all. Let's start discussing about one hot encoding first. So what is one hot encoding? One hot encoding, for suppose, imagine there is a data set or there is a column present, which is gender. There is a column present, which is gender. So gender will have either male or female, right? We don't have most of the other values, only male and female, limited values are present. So it may be male and again male. Okay, there is a column called as gender, which is having few values like this. It will have only limited values. There is no further appearance of any other values in this, either male or female. So whenever you are having limited values, how can we say feature or a column? Whenever a feature or a column is having a limited values, then such column is called as a factor. So whenever a column or a feature is having limited values, such column are called as factors. In here, gender is a factor because it is having limited values. What are the limited values? It may be either male or female. So whatever the different values present inside, those are called as levels. So this is a factor. This we can call the gender is a factor with two levels. So what is two levels means? Factor with two levels because we have only two values present inside, either male or female. So this is the name that you have to remember, that is factor. Okay, so we are about to talk about binary encoding or one hot encoding. So what is binary and what is one hot? So here, as the name indicates, binary is nothing but zeros and ones. Okay, let's see what is zeros and ones. Okay, so what did I talk about? Here I have an example of column called as gender. Gender is having either male or female or male, male, female, and so on. Now, what is my purpose is, this categorical column is there. I want to convert it into numerical based on my machine learning algorithms. Depending on my machine learning algorithms, I want to convert it into numerical columns. Now, how to do this when we are using one hot encoding or binary encoding? So here, how many different levels are there? Number of levels. If there are n levels, then you will get n different variables or features. In one hot encoding, if you are having n levels, so as I told, if you are having limited values in a particular feature or a column, that is called as a factor. Within the factor, the limited values are called as levels. If you are having n levels, the total number of variables that are about to create in one hot encoding are also n. So what is this one hot encoding? What will get created here? So here, whatever the levels are there are two levels. One is male, and second one is female. These will be your separate variables. One will be male and second one be female. And how will I convert this categorical into numerical using this binary encoding? So wherever you have male, under male you will get 1, female is 0. Here female is there, so male is 0, female is 1. Male is there, female is 0. Male is there, female is 0. Female is there, so male is 0, and so on. This is how we will do the process called as binary encoding or one hot encoding. So in one hot encoding, you have to remember, if there are n different levels present in a factor, you will get n different variables. So two levels are present. So two variables I got. Let me take one more example and show it to you. Okay, I will take one more example. For suppose I have one more data which is belonging to cars. So make of car, whether it is electric car or diesel based car or petrol variant car, whatever it is based on this column. Okay, now I have, first one is petrol. Second one I have is diesel, maybe CNG, maybe electrical. There may be multiple different types of cars present. Okay, so here in this particular column, I have one is petrol, another one is diesel, CNG, electrical, petrol, and so on. Now, if I am about to do one hot encoding, what did I tell you? So number of levels, based on the number of levels, I will get the number of variables. So here, how many levels are there? P is one level, which is petrol, diesel is another level, CNG, and electrical. 4 levels are there. And also there may be maybe one or two extra, but multiple values are not present in this particular column. If a column is having limited values, this is called as a factor. And how many different values are there? 4. So this is a factor with 4 levels. So if there are 4 levels, so the number of variables that are about to be created are also 4. Now, how to do this? One hot encoding or binary encoding. Petrol is present here, so this is 1. Remaining else are 0. Diesel is present, so this is 0. Diesel is 1. Remaining else are 0. Diesel is present, diesel is 1. Remaining else are 0. And CNG is there, so CNG is 1. And remaining else are again 0. And electrical, this is 1. And remaining are 0. And petrol 1, remaining are 0. And so on. This is how we will do the process called as one hot encoding or binary encoding, which is one of the encoding technique present. So encoding is nothing but converting categorical into numerical, within which we have multiple methods present. The first one we have is binary encoding or one hot encoding. As the name indicates, binary is nothing but zeros and ones. We are converting the categorical data into numerical based on zeros and ones. In one hot encoding, you have to remember, if a column is having limited values, that column or feature is called as a factor. And whatever the values that are present inside the factor are called as levels. And also, here in this example, this is the make of car is a column or a feature which is having limited values. So this is called as a factor. And this is a factor with 4 levels. And also, this is how we will do one hot encoding. And now let's see what are the other encoding techniques present. Okay, so the next one that we have, so here is an example. Okay, here is one more example present. So there is a column which is education level. So in this education level, there are only limited values. High school, one is high school, second one is bachelor, third one is maybe master's, and fourth one is doctorate. Okay, 4 levels are there, which means this education level is a factor. It is a factor with 4 levels. So there are 4 levels. So in one hot encoding, it will automatically create 4 variables. What are 4 variables? These are the 4 variables: high school, bachelor, master, and doctorate. This is how we will do one hot encoding. Okay, fine. Now let's see what is present next. So this is binary encoding or one hot encoding. The next one that we have is ordinal encoding or label encoding. So what is ordinal encoding or label encoding? What is this type of encoding here? So as the name indicates, label encoding, this will be based on labels. For suppose see here you have a column called as gender, the basic example. Gender is there. So within this I have male, female, male, and so on. Now I want to convert this categorical column into numerical using label encoding. So here what happens? As the label encoding indicates, it will be based on alphabetical order. So I have alphabets like A, B, C, D, E, F, G, H, I, J, K, L, M. So if you observe, out of 2 alphabets present in the 2 words male and female, female comes first. So in label encoding, what happens? Female will be allotted with number 1. And after that, I'm getting M. So it will be allotted number 2, 1, and so on. This is how we will do the concept of label encoding on categorical columns. So here, label encoding is of again 2 types. One is nominal encoding and second one is ordinal encoding. So you already learned about the data types nominal and ordinal. If you observe, this male and female, this is not ordinal data, this is nominal because there is no order present in these values. If you observe this one, education level column present here. So first of all, there is a level. Like what? First, we will complete high school. After completing high school, we will do bachelor's. After bachelor, we will do the master's, and then we will do the doctorate. So there is some order present. So this comes under the type of label encoding called as ordinal encoding. Ordinal encoding. So see here. So based on these levels, I am giving the values. So high school will be always 1. So high school will be always 1. Bachelor is 2. Okay, I'll just write it with some other color. High school is always 1 because this is the first level. Bachelor is 2. High school is again 1. Masters is 3. Doctorate is 4. Bachelor is 2. Masters is 3 again. High school is 1. Depending upon this, we are giving the labels which is called as ordinal encoding. So, label encoding is again of 2 types. First one is nominal and second one is ordinal. When your data present in the column, categorical column is nominal, you will go for this type of encoding based on the alphabets, and ordinal encoding, we will go based on the order. Now, you also have one more thing present, which is called as lexicographic method. So what is lexicographic method? So that is one more method which is called as lexicographic method. So in lexicographic method, what happens is, instead of understanding only the first letter of the alphabet, for suppose as we told, as we have taken an example before, like what? Maybe there are alphabets in a column like bus, car, train, so on. So there are different types of transportation present in a column. So here, if I want to convert this categorical column into numerical based on this lexicographic method, what happens? So first we will compare. Out of 3 alphabets, B, C and T, B comes first. Okay, fine. Next, it will compare the second alphabets also. So out of U, A and R, A comes first. Okay. And this is having a lot of lengthier string compared with the other 2. So this will be obviously 3. And out of these 2, let's make the comparison. So U is second. This will be first. This is second. Now compare the rest. This is first and this is second. So you will get car, you will get 1. Bus, you will get 2. And train, you will get 3. This is nothing but lexicographic method. So in lexicographic method, instead of understanding only the first letter of the word, you will go for the entire letters of the word. That is called as lexicographic method. And there is also one more thing which is present in the slide. See here. So this is rank transformation or ordinal encoding. And the next one that we have is attribute construction. So what is attribute construction? There is no column called as education years. But how did I get it? Based on the available data, I am creating a new input. Based on the available inputs, I'm going to create a new input, which is called as attribute construction. So I've just got some idea, like the person, whoever is completing the high school, maybe having the educational years, which is 12. He may be having 16. I imagined I created this particular column, which is called as attribute construction. These are the different methods present by which you convert a categorical column into numerical column. So what are those? The first one that we have is one-hot encoding or binary encoding, in which we will convert or we will have a name called as factor. Factor is a feature or a column which is having the limited values, and within that the values are called as levels. And how many levels are there? For suppose there are n levels present in your columns. So in one-hot encoding, you will obviously have n variables created. And coming to the label encoding, so in label encoding, okay, so in label encoding, you have again 2 types, nominal and ordinal. Nominal encoding is when the column data is in nominal order, you will go for nominal encoding, in which we will select or we will see the alphabets, the first alphabet of all the words. Then we will just give the marks like 1, 2, 3, and 4. That is called as nominal. Ordinal is nothing but based on the order, you will convert that into numbers. And attribute construction is nothing but based on the available data, you will be creating a new input which is called as attribute construction. And lexicographic method is the method in which instead of looking at the first letter, you will look for all the letters in the entire word and you will check out which comes first. That is nothing but lexicographic method. And there is one more thing which is nothing but dummy variable creation. Let me tell you that one. Okay, so there is one more concept called as dummy variable creation. So what is dummy variable creation? So there is a small difference between one-hot encoding and dummy variable creation. I'll tell you what. So I'll tell you here. So there is one more concept called as dummy variable creation. So what do you mean by, you may have heard this word before. There is one more thing which is dummy variable creation. And what is the purpose of this dummy variable creation, and what is the difference between this one and one-hot encoding? So as I have told, whenever we are having n levels in a factor, in one-hot encoding, you will have n variables. But in dummy variable creation, when you have n levels, you will have only n minus 1 variables. How? I will show it to you. So I will take the same example like before, which is gender. So there is one example called as gender. Gender, we have male, female, female, male, and so on. Now I want to convert this into numerical column based on one-hot encoding. So there are n levels, so it will take n variables, which means one will be m, one will be f. This is nothing but one-hot encoding, which we have seen before, and so on. Now coming to the second one, which is dummy variable creation. Here also I'm taking the same example, gender. So gender is again having male and female, female, male, and so on. Now in dummy variable creation, there are two levels. Here this gender is a factor with two levels, that is one is M, which is male, and second one is female. This is a factor with two levels. Now, as I told, in dummy variable creation, you will have only n minus 1 variables, which means 2 minus 1, that is 1 variable. What is 1 variable? Here I will get a variable. So in that variable, it will tell you whether it is 1 or 0. Male, if it is male, it is 1. If it is female, it is 0, 0, 1, and so on. This is nothing but dummy variable creation. So there is a difference between one-hot encoding and dummy variable creation. What is it? In one-hot encoding, if there are n levels present in a factor, what happens? It will automatically create n variables. But in case of dummy variable creation, it will create n minus 1 variables. Now let's see how to do the discretization in RapidMiner Studio. So let me go back. So let me open this one, which is RapidMiner Studio here. Now I will just delete whatever that we have done before. This is regarding the detecting outliers process. I'm deleting this and also this. Now I'm going to use the basic data set, which is sample superstore. So as I already imported that into my RapidMiner Studio in the previous session, which is present in my session repository in the data subfolder, I will just connect with this by dragging and dropping it into the process. What is it? Titanic is the default data set which is already there in RapidMiner Studio. But now for this discretization process, I'm going to use the data set which is sample superstore, which is an Excel sheet that is present in my local machine. I imported that and saved it in a repository called as session in my RapidMiner Studio. Okay, now let's see how many columns and how many records are there. In order to execute this process, you always have to connect the output port to the response port, make the connection, and execute the process. Once you execute the process, you can see 997 records and 21 columns. Okay, now I'll go back to the design. Now what I do is, I want to just convert, or what is that? I want to perform discretization in RapidMiner Studio. So just type discrete in operators. You can see a lot of different things coming. Discretize by size, discretize by binning, by frequency, by user specification, by entropy. There are different things present. So basically we will use in RapidMiner Studio, which is discretize by binning. So what is discretize by size? So this method will divide the data into equal sized bins. That is based on size. Discretized by binning is nothing but based on the range of attribute values, it will automatically divide it into bins. Based on frequency is nothing but how frequently a value is occurring. Based on that, it will just create the bins. So there are different methods or operators present in RapidMiner Studio, within which I'm going to use the operator discretized by binning. So Always remember, you have to establish the connection between operators in order to make it work. Now, you have to customize your operator, which is discretize. I don't want to convert all the columns into numbers. That is not needed for me. So what I do is, discretization means what? We are converting numerical data into categorical. So here, I'm going to the parameters and I am just selecting only a single column. So I have to select a numerical column. So I will select sales. Out of all the columns, 21 columns, these columns are only the numerical columns present. That is why only these are present in the drop-down. So apart from these columns, rest of all are categorical. But discretize operator will convert only numerical into categorical. That is why it is showing only the numerical columns. Now, out of all the columns present, I will choose sales. So I have a sample superstore present, which is having 21 columns. Out of 21 columns, I want to discretize or convert a numerical column called as sales into categorical. Okay, so how many bins you want? How many bins you want? I want 5 bins. I want 5 bins. And range, you can select here the drop down. Short, long, or interval. I'm not changing anything, okay? I'm retaining it as is and I'm just executing this process. Now, if you see here, I will go to the statistics and here under the sales, you can see there are 5 different ranges came. This is how you will discretize the data based on your requirement. Whether you want to convert a specific column or all the columns, it depends upon you. These are the various operators present. You can explore all the operators. You can see the description also by right-clicking on the operator and clicking on F1. Okay, this is how we will do the process of discretization. And what? And the next one we have is encoding. We are converting numbers into categories. I told you this before. I will delete this discretize. Instead, I will select only few columns out of all, which means I am using select attributes operator and establish the connection between these two operators. If you want to customize, you can go here and select whatever that you want. Okay, I am selecting here. What is this one? This is encoding. Encoding is nothing but we are converting categorical, or we are using the operators like numerical or to binomial or numerical to polynomial, just like that. So you can use either discretize by binning, discretize by size, or you can also go for numerical to polynomial or numerical to binomial. So I'm selecting here only one column, that is sales. That is sales. Sales column selected. Now I will use numerical to binomial and establish the connection. Use numerical to binomial. If you want to customize your parameter, what you have to do, click on the operator. On the right side, you have parameters where you can do the customizations. So here, I will just take the minimum as 1000 and maximum as 5000. Okay, this is my range. You can give whatever you want. In order to execute the process, you have to connect it to the response port. So true are the ones which are satisfying or in the particular range that I've provided, and false are the ones which are not present in that range. These are the two categories. This is how you can do discretization in RapidMiner Studio. Okay, this we have already seen. This is how you can do the discretization. Okay, so if you want to see only true or only false, I told you before, you can go for filter examples also. There is one more operator called as filter examples. If you want to just get the values or the records which are present in this range, you can go for true. If you don't want, if you want only the values or records which are not present in this range, you can go for false. That is how you can just use all the different types of operators present in RapidMiner Studio. Okay, this is about discretization and encoding. Now let's see what is present in the slides. The next one that we have already discussed is the feature engineering or attribute construction. So here, there are various examples provided. Let's see the credit card example. So there is an example provided, which is credit card. So what is this credit card example? For suppose, what I have is, I want to predict whether the transaction that was done using this credit card is fraud or not. So there is an output variable, that is whether the transaction is fraud or not. Fraud or not fraud. Now, there are also some inputs present. What are those inputs present? Which means there is one input variable where the previous transaction happened, which is the place of previous transaction. There is one input variable, I can name it as, or it was talking about the place of previous transaction. And there is one more, x2, input variable, which is talking about the time of previous transaction. At which time the transaction was happened before, the time of previous transaction. So we can take any example. And there is one more input variable which talks about what is the place of the current transaction. What is the place of current transaction? And the last one I'll take maybe the fourth input variable, the time of current transaction. So these are all the data present. Based on this data, I have to understand whether the transaction that was made is fraud or not. That is a prediction model. Now, here, based on the inputs which are already there, I'm going to create a new input. If I am going to create a new input from already existed inputs, that concept is called as attribute construction. So what can I create newly from these existed ones? So for suppose, if I take these two, I'll take these two columns and I will create a new column. What is that new column? Maybe I'll create a distance. I can calculate distance. So from the previous transaction to the current transaction, according to the place, I will find out the distance. And based on the other two columns, the time, I can find out the time log. What is the time difference present? So just like that, if I can create new inputs from already existed inputs, such type of concept is called as attribute construction. Okay, this is one small concept present. Let us move on. Okay, the next important thing that is present over here is missing values. So what is missing values? You already know this concept of missing values. So what do you mean by missing values? So let us move on to the mind map first and see after zero variance features what is present. We have discussed up to here. Let's see what are the rest present. The next one that we have is discretization, which is also called as binning or grouping, which means we are converting continuous data into discrete data. And here we have binarization, which means we are converting the continuous data into two categories, and rounding is present. Rounding is nothing but we are rounding it to the nearest value, whether it can be floor or ceiling, anything is fine. Now the next one is binning. Binning is of again two types, fixed width binning and adaptive binning. Okay, discretization is fine. And what about the dummy variable creation? So there are different methods present in which we have discussed one-hot encoding and label encoding, which are the important ones. And after that, we are about to see the most important one, which is missing values. So in your raw data, for sometimes you may find missing values present in a lot of different columns. So missing values, if you find any, you can go for different types of methods in order to impute them. So first of all, what is imputation? I'm telling for missing values, I'm going for imputation. So what is imputation? So imputation is nothing but replacing the missing value with some logical value. So wherever the missing value is present, we are replacing it with some logical value, which is called as imputation. So replacing the missing value with logical value is called as imputation. There are various methods present and also various variants present. So what do you mean by variants? So first of all, imputation is nothing but replacing the missing values with some logical values. I'll delete this one. After that, see here, imputation is having variants. In variants, there are three most important variants. Missing completely at random, missingness at random, missingness not at random. And there are also different techniques present. We will see this in the form of slides. Okay. So here, first of all, let's talk about the variants. So there are three variants, missing completely at random. The first one that we have is missing completely at random. So what is this one? If you see here at the bottom, an example is given. So a person is there. There is a person who is just noting down. Okay, there is a person who is noting down the information of other people So see, what is your name, what is his age, what is the gender, and whether he or she smokes or not. This is the information that that person is noting down. If you observe here, there are fewer missing values present in the process. Why? Why is that happening? Why we are having missing values here? What may be the reason present here? So here, the reason may be of multiple types. So first one we have is missing completely at random. So in here, if you see this one, there is one person present. After that, he just entered the information of that person which is proper. After that, a group of people entered the room at the same time. So in the meantime, while entering the information of multiple people at once, he may missed some values while entering those records. Okay, while entering the information, he may missed those because of entering multiple information at the same time. So whenever the cause of missing values, the cause why the data are missing, the cause why the data are missing is unknown, that particular variant is called as missing completely at random. So the missing values are happening because of some random reason. There is no particular reason. The missing value is not, sorry, the reason or the cause for which the data is missing is not known. That scenario or the variant is called as missing completely at random. So what about the second one? What about the second one? So there is a second one present which is missing at random. So what is missing at random? If you observe an example provided here at the bottom, these are some simple examples here to make you understand properly. So here also the same scenario. There is a person who is entering information, but here there are only two people. One is here the Jansi and second one is Jennifer. So when he is noting down the information for the first person, so he asked like whether he or she smokes or not. He asked that question. So she did not answer that particular question. She simply smiled. You can see the emoji here. So she simply smiled and did not answer to the question. So he may think like maybe she smokes and she felt shy to answer the question. That is why she did not answer. Or he thought like maybe she didn't want him to know whether she smokes or not. There may be multiple reasons. So here, in this particular scenario, the cause for which the data are missing is known but not certain. I can guess the reason that maybe there may be multiple reasons. Maybe this one is the reason for missing value, but it is not certain. That is not accurate reason. That is where we have the second variant called as missing at random. So missing completely at random is nothing but the values are missing because of the reason which is not known. That is nothing but missing completely at random. Whenever we have the second one, which is missing at random, the cause is known, which can be guessed, but it is not certain. Apart from these two, there is one more which is missing not at random, which means here we absolutely know why the data is missing. So what is this? Here in the third case, the reason is certain. The cause for which the data is missing is certain. So what is the reason for this particular example over here is, here there is a community present in the second sheet over here. If you observe, there is a community present in which asking about the questions like whether a person smokes or not, whether a lady smokes or not is not allowed. So that is why there is no value present in the smoke column in this particular community. So when you are having null or NA, that means there is missing values or null values present in your data. So in such scenarios, it may be any one of the three reasons present. It may be because of missing completely at random, which means the reason for which the data is missing is not known. And the reason is guessed, but it is not certain when it comes to missing at random. But the third one that we have is missing not at random, which means the reason for which the data is missing is known for us. These are the three variants present for missing values. And then I will just clear these things. Apart from these three, what else are there? In order to handle these missing values, we again have a lot of different methods. The first one that we have is deletion methods. In deletion methods, we have the first one, simple strategies. So simple strategies, again, we have two types. First one is case-wise deletion. Second one is pair-wise deletion. So in case-wise deletion, what happens? See here, there is an example provided here. So in this particular example or data set given, there are few records which are having missing values. In case-wise deletion, what happens? Whatever the records that are having missing values will get automatically deleted. See here, if we are having missing values here, this record will also get deleted. That is the simple strategy called as case-wise deletion. Case-wise deletion is also called as list-wise deletion, and it is also called as complete case analysis. Okay, so there is a second one. There is a second one called as pairwise deletion. What is pairwise deletion? What is pairwise deletion? Pairwise deletion is also called as available case analysis. In here, again, the same example is given, but here what happens is we will calculate the correlation between all the columns. First, what we will do, there are total 5 columns present. One is name, second one is age, third one is gender, fourth one is whether he or she smokes or not, and fifth one is income. So in pairwise deletion, what happens is we will calculate the correlation between all the columns for all records. If you see here the first record, so there are all values present. All the values are present. So you will get some value for correlation. But whenever we are finding out the correlation between two columns which is having the missing values, for suppose name and age are there. Here the value is not there. So we will get an error while performing the correlation. Why? Because the value is missing. So in such type of cases, based on correlation, we will delete the records where we can't find the correlation. So in pairwise deletion, for the records for which I can find the correlation for all the columns, those records will be retained. Otherwise, those are get deleted. Otherwise, the else are get deleted. What are those? Whichever the columns for which I did not find the correlation for all columns. Where I can't find the correlation, where I have a missing value. That is nothing but pairwise deletion. But out of the two that we have discussed, which is the case-wise and pairwise, the first is the easy one because in this second pairwise deletion, there is a complexity involved because of this correlation step. We have to calculate correlation for every column. This will take a lot of time. This is pairwise deletion. So, in order to handle those missing values, we have the simple strategies present. The first one is case-wise deletion, and the second one is pairwise deletion. And there are also some of the other imputation methods present. Before going into that, we will again have a quick 10-minute break and we'll get back. Okay, everybody, let's continue with the session. So what we have discussed before, we are talking about the missing values. So in missing values, we have three variants. What are the three variants present? The three variants that we have is missing completely at random, missing not at random, and missingness at random. Just give me a second. Missing completely at random, missing at random, missing not at random. These are the three variants present. So each of these variants is having a specific reason. So missing completely at random is the one where the missing values are there, but we don't know exactly why they are missing. The reason for which the data are missing is not known here. And coming to the second one, missing at random, where in this particular variant, the reason can be guessed, but that is not 100% sure whether it is right or not, which means the reason or the cause for which the data is missing is known, but it is not certain. And missing not at random is the one where the reason is completely certain, which is we know exactly why the data is missing. And coming to how to handle those missing values, we have two types of simple strategies of deletion methods present. The first one is case-wise deletion, which means wherever the records are having the missing values in the entire data set, those records will get deleted. So case-wise deletion is also called as list-wise deletion, or it is also called as complete case analysis. And the second simple strategy that we have is pairwise deletion or available case analysis. In this particular method, in this deletion method, we are calculating the correlation between two columns of all the columns in the data set. Based on that correlation, we are deleting the set or the record which are having missing values. But compare with the two simple strategies present, the case-wise deletion is the easy one. Whereas in pairwise deletion, we are having an additional step of calculating the correlation. And apart from that, what else we have? So we have again the next one, which is imputation techniques. So what are the simple imputation methods present? As I told before, imputation is nothing but the replacement of missing values with some logical value. So what may be the logical values? Here, if you see the statistical imputation, here we are about to use measures of central tendency. We have already learned the 4 business movements, out of which the first business movement is called as measures of central tendency. Within that, we have mean, median, and mode. You can see here under the statistical imputation techniques, we have mean, median, and mode. So, first suppose if you have a column, if there is a column that is categorical, and within the categorical column, I have some missing values. Within the categorical column, I have missing values. Now, how to do imputation in that particular column? I told you there are different statistical imputation methods present, which are based on measures of central tendency. What are those? One is mean, second one is median, and third one is mode. But now my scenario here is I have a column present, which is a categorical column. So in that categorical column, I have missing values and I have to go for statistical imputation. So which imputation method I can go for out of these three present? So that is a categorical, I can't go for mean. That is categorical, I can't go for median. So simply I'll go for mode imputation. So depending upon your purpose, you can choose whatever the imputation technique that you want. Let us see an example is given over here. So here there is a data set present. Okay, there is a data set present, out of which the first column that we have is name, age, gender, smoke, and income. Name is not having any missing values. What is it? Name is the column with no missing values. Name is the column with no missing values. And then what? There are missing values in age column, gender column, smoke column, and income column as well. So what I told, we have different imputation methods present. Like what? Mean, median, and mode. So there are different imputation methods present. The first one we will see is age column. So in age column here, there are missing values in this record, How to replace these missing values with some logical value using this imputation? Here, this is a numerical column. I can simply go for mean. You can also see that that is a numerical column. So I can also go for median. Why not median? Why only mean? So there is again one more case, like if the column that you are dealing with, the missing values, is a numerical column. It is a numerical column. And within that numerical column, if the data is normal, if there are no outliers, then you can simply go for mean. Because mean will get influenced by the outliers, which we have seen in example manner in previous session. So when your numerical column is having outliers, you can simply go for the imputation technique called as median. So for the age column, he had calculated mean 28. So wherever the missing values are there, that will be replaced with this mean value, which is 28. This imputation is nothing but mean imputation. Why? Because here the missing values are replaced with some logical value, that is mean value. So this is called as mean imputation. Coming to the gender and smoke, there are only two categories present, like two values, zeros and ones. You don't need to calculate mode. So mode, the mostly occurred is 1. So I will replace it with 0. Here it is 1. I will replace it with 1. So wherever the categorical values are there, you can simply go for mode. Or wherever the numbers are only zeros and ones, you can go for mode. And then the last column that we have is income column. In income column, I have a missing value here. And I want to replace it with some logical value. But when I observe this income column, I have an extreme value present over here, which is an outlier. So out of the two different statistical techniques present, mean and median, I can't go for mean because there is outlier present in my data. Mean value will get influenced, so I can't calculate mean. So I will simply go for median. So median is 3120. The missing value will get replaced with the median. This imputation is called as median imputation. So imputation is basically, it is a technique where we will replace the missing values with some logical value. There are a lot of different imputational methods present. The first one is mean, second one is median, and third one is mode. And what about the rest? What are the other things present? The next one that we have is random imputation. So in random imputation, what happens is, for suppose, there is this age column. On age column, wherever the missing values are present, I want to replace it using the imputation method called as random imputation. So how to do it? In random imputation, what happens is, we will replace the missing value. We will replace the missing value with the random value, with a random value. You can ask the question like any random value. No, not any random value. With a random value within that range. Range you already know, maximum and minimum. Within the range of the column, any random value you can take and you can replace the missing value with that random value. So range of column. So you have to observe the minimum and maximum. When we just observe the age column, what is it? When I observe age column here. So age column is having the max value, that is maybe 44. And the minimum value that I have is 26. Yeah, 26. Okay. So now wherever the missing values are present, I can replace it with any random value in between these two numbers. It may be 27. It may be 43. It may be 26. It may be 44. It may be 40. It may be 39 and so on. But I can't replace it with 20 or 10 or 50 because that is not present in the range. So within the range of the column, whatever the values are there, you can select any random value and you can replace the missing value. That is called as the imputation method called as random imputation. The next one that we have is, what is the next one present? Let's see. The next one that we have is hot deck imputation. So we mostly prefer mean, median and mode, but these are the other things present. So hot deck imputation is nothing but, in hot deck imputation, wherever the missing values are present, we will match that record with the rest of the records. For suppose you have here new column. new record 4, 28, 1, 1, and 3120. So this record is matching with this new record. So what you do is here, whatever the value is present in that age column, that will get replaced in that particular cell. That is called as hot take imputation. In hot take imputation, wherever the missing values are there, that record will be compared with the rest of the records in order to find the matching one. So wherever the match is found, that value will get replaced in that missing value cell. So if it is missing here, this is 1. So if this is not matching, so for suppose I got one more record 631, 0, 1, and 3400. If you observe this column, sorry, this record and this record, these are same. So I will replace this with 0. That is hot take imputation. For suppose you may get a doubt like, for suppose I did not find any matching record. So 4 is there, I don't find any 4s here. So what happens in hot take imputation is, it will start deleting the columns one by one and again compare one record with the other record until the match is found. That is how the hot take imputation works. So apart from the deletion methods, you also have a concept called as replacing the missing values with some logical value called imputation. In imputation, you have multiple statistical imputations in which we use measures of central tendency, mean, median, and mode. And also there is one more thing which is random imputation, where we will replace the missing value with some random value which is present in the range of that column. And then we have hot take imputation present. Hot take imputation is nothing but wherever the missing value is present, that record is going to match with the rest of the records. Wherever the match is found, according to that record, the missing value will get replaced. Okay. Apart from these, there are also again other types of imputation present: regression, KNN, iteration, and multivariate imputation. We will see all these types, the other types of imputations in predictive modeling. So the rest of the imputation methods that are present, we will see or discuss about this when we are talking about predictive modeling. Right now, up to hot take imputation is enough. Okay. Now let's see what is present in the mind map. What is present in the mind map? Let me open the mind map. So here is our mind map. In missing values, we will do imputation process, and also there are 3 important variants present: missing completely at random, missingness at random, missing not at random. And then what? There are also various techniques present. So in these techniques, we have deletion methods. Deletion methods means case-wise and pair-wise simple strategies which consist of case-wise deletion and pair-wise deletion. Simple imputation methods consist of mean imputation, median, mode, random, hot take, regression, and KNN. So mean imputation. So mean imputation, this is based on Python. You just have to learn different types of methods. And model-based, you have one more thing, which is multiple imputation and maximum likelihood. We will talk about this later. This is about missing values. Now let's check it out. How to handle the missing values in RapidMiner Studio. How to handle those in RapidMiner Studio. So let me just have a data set with missing values. In our sample superstore, there are no missing values. So let me see whatever the data set that is having missing values. I created one, I guess. Let me see. There is a data set that I've created which is missing values. That is some sample data which is having missing values. That's it. Let me open it and show it to you. So here what I did is I created one data set which is having missing values. This is basically education data set. You already have this one where I have deleted few records to get the missing values. So let me just use this data set in RapidMiner Studio and work with that. How to just handle the missing values. Let us see. I'll go to this RapidMiner Studio. I'll delete whatever that I've created before. And now I want to get that Excel file, which is missing values Excel file. So in order to get it, I don't want to import it into the repository. So I will simply use the operator read Excel. I'm not going to import and save it into my repository panel. I just want to connect with that data from my local machine. So I am using read Excel operator. So read Excel, double click on the read Excel. Now I'm going to connect with the data set which is having missing values. Click on next. Here you can see the missing values present. I don't want to change anything. Click on next again. I don't want to format the columns. There are no problems in my data set. Everything is working fine. Click on finish. After clicking on finish, if you want to see your data, you have to execute it. How to execute the process? You have to connect the output port to the response port and click on this play button. You will get, there are totally 25 records and 3 columns. 25 records and 3 columns. Now, how to handle your missing values? How to handle your missing values? You can use different operators. So see, you can impute your missing values. You can replace your missing values. There are multiple operators present. First, let me show it to you. Replace missing values description. So here, what is the use of replace missing values? So here, this operator will replace the missing values of selected attributes by a specific replacement. And what about impute? What about impute? Let me show this one as well. So description is that this operator estimates values for the missing values of the selected columns by applying a model learned for missing values. So right now I don't want to go for the model. I just use replace missing values only. So replace missing values. And while you are using the operators, always I told you, you have to make the connection between the operators. So take the output of read Excel port as input to the replace missing values. After that, you always have to customize your operators with the help of parameters only. Now, what you want to find? If you want to find, for suppose, if you see here, just let me show the results first. So wherever you can see the question mark, wherever you see the question mark, that is the indication of a missing value. What is it? So in this RapidMiner Studio, question mark is nothing but a missing value. So you already know average is nothing but mean. Now, if you observe this, there are no outliers present, right? Everything is present normally. Now what I do is I'll go for replacing it with mean imputation because everything is a numerical column. I'll go for mean imputation, which means average imputation. Mean is also called as average. You already know this one. So I will go for imputing the values based on mean. So how to do it? I'll go back to here to the design view where I have this operator. In order to customize this one, I have parameters where I can choose what is that I want. 0, value, average, max, minimum. I want average imputation. I'll click on. So in order to execute this process, before executing, you have to make the connection between the operator and the response port. After making the connection, you have to execute this process. Once you execute this, now you can see there are no question marks present. Everything got replaced with the mean value. So in the statistics, you can see there are no missing values, 0, 0, 0. If you want to see the comparison, you have to use the operator, that is multiply operator. You have to use the operator multiply. How to use it? Multiply, take it here. Connect the output port of read Excel as input to the multiply and connect this output port to the response and the second one as input to this one and connect it to the response port. So now you can see the comparison between two copies. One is original data and second one is the data where I have replaced my missing values with average value. So this is how you have to create your process. After creating it, by making the connections between the operators and the response port, you have to execute it. Now, this is my original data, which is having question marks present here. So here, the 7th record work experience, I don't have any value. In this replace, I got replaced it with 78 because that is the mean value. So here, see, here again, 17th record, it should replace with 78 again, 78 and so on. This is nothing but how you do the imputation in RapidMiner Studio. We have seen typecasting, which is changing one data type into another data type. We have also seen how to handle the duplicates. Basically, in real time, we will go for multiple ways of handling the duplicates. But in RapidMiner Studio, I have shown you remove duplicates operator present. And the third one that we have discussed is outlier analysis, within which we have multiple methods like 3R technique, Winsorization, trimming, and also we have discussed like the words like masking and swamping, and identifying the outliers using IQR approach or standard deviation approach. And I've shown you how to handle or treat the outliers, detect the outliers using distance, density, multiple ways, or multiple operators in RapidMiner Studio as well. And the next one that I've shown you is zero or near zero variance features. So whatever the columns that are having a single value in all the records, that is zero variance, or whatever the column that are having most of the proportion occupied by a single category, that is near zero. If it is a categorical column, we will go for proportion. If it is a numerical column, you will go for variance. If the variance is 1 or less than 1, you can remove that column. That is nothing but variance or near zero variance features. And we have also seen about discretization and encoding. Discretization is nothing but converting a numerical column into categorical column. And then encoding is nothing but the reverse of it. We have seen all those things, how to do it in RapidMiner as well. And the last one that we have discussed is missing values. This is how you will do or handle the missing values in RapidMiner Studio. So always, if you want to check it out, whether the original data and the data after the execution of the process using different operators is changed or not, you can use multiply operator. Okay, let us go back to the slides and see what is present next. The next one that we have is data transformation. What is data transformation? Why do I have to go for data transformation? So when your data is not normal, what is it? What can I say? When your data is not normal, normal distribution we have talked about before. If the data is not distributed across the mean and the right and left are not symmetrical, that is called as non-normal distribution. So if the data is not normal or if the data is not linear, I can just apply transformation methods. Why I have to do the data transformation? So that I can convert that into normal distribution data or linear data. That is why we use transformation. So if the data is not normal or not linear, when I do the transformation, I can convert it into normal distributed data as well as linear data. So there are multiple different types of transformation methods present. Let us see what is there. So here, transformations are of different types. The first one is log transformation. The first one is log transformation. And the second one, what is the second one? Exponential transformation. You already know about the curves. If you plot a chart and if you are having an exponential curve like this, maybe like this, an exponential curve like this. So when you are having an exponential curve, you should go for log transformation. When you are having a log type of curve, you have to go for exponential transformation. So what is log curve looks like? It maybe looks like this one. So there is just normal increase and then rapid increase. That is how you have to just understand the concept of this transformations. And what else are there? There are others also present, like reciprocal, power, square root, cube root. So here see, power transformation is nothing but x square, x cube, just like that. In square cube, if it is 2 in the power, that is square. If it is 3 in the power, that is cube. And polynomial transformation, you already know about polynomial with 2 degrees, 3 degrees and all, which we have seen in the previous session. If we are having one curve, if we are having one bend or one curve, then what can we call this as? This we can call it as polynomial with 2 degrees. And if we have two bends, 1, 2, we can call it as polynomial with 3 degrees. So this is how you have to understand the concept of polynomial, which we have talked about. That is polynomial transformation. Reciprocal is reverse. If we have an input variable x, in reciprocal transformation, what happens? It will become 1 by x. That is reciprocal transformation. And there are also, again, two more important ones. That is Box-Cox and Yo-Johnson. So what is Box Cox and what is EO Johnson? So when do we prefer these? So in both of these different transformations, the lambda value will change. In both Box Cox and EO Johnson transformation, the lambda value will change. Based on the lambda value, you will just understand what type of transformation technique that you have to use, whether it is square root or log or exponential, just like that you have to understand. So this is properly present in the mind map. Let's check out what are all the lambda values present in the mind map. So let me go to the mind map here. You have the next one, that is transformation here. Open the transformation. So in transformation, we have different techniques present. In Box Cox, if you observe, based on lambda value, you have to understand which technique you have to use. Okay, now here, lambda is equal to -3 implies this one. If it is minus 0.5 or if it is 0.5, you have to go for square root. If it is 0, you have to go for log 1 by square root. Just like that, the lambda value will indicate the transformation technique. In EO Johnson also, the lambda value changes. Here, if it is 0, that is log. If it is 0.5, that is square root. But why do we need two different transformation methods which only depends on the lambda value? Why? So when your data or the column that you're working, which is not normal, is having only positive values, only positives are there, then you can simply go for the transformation technique called as Box Cox. But EO Johnson also works with when your column is having negative values as well as zero values. That is nothing but EO Johnson. This is the simple difference between the two transformation methods present. So Box Cox and EO Johnson are the two transformation methods present in which lambda value changes, but Box Cox works well with the positive values, whereas EO Johnson works with negative as well as zero values. This is about transformation. Now next that we have data scaling or feature scaling. I will show in RapidMiner how to do it as well. Let me open the slides and check what is present under the data scaling. So in data scaling, it is also called as data shrinking or feature scaling. We have three methods present. So let us see what is that. Sorry. So here, the next one that we have is normalization, standardization, and drawbar scaling. We will hear about normalization and standardization later when we are talking about the machine learning algorithms mostly. So here, what is normalization? When do I have to go for normalization? When do I have to go for standardization? And when do I have to go for this drawbar scaling? So I'll show you simply with the help of a data set, which is CARS data set. You have CARS data set, right? Let me open and show it to you, the CARS. Before that, understand the concept here. So here, if you observe normalization, which is also called as min-max scaling method or range method. So that is x minus minimum of x by maximum of x minus minimum of x. So what is normalization, what is standardization, and what is drawbar scaling? First, suppose if you have a column which is having huge data, which means 6-digit number, 7-digit number, just like that you have multiple records of very big values. So if I want to perform anything on that, it may not make sense because of the huge data. So simply what I do is I'll just scale this data into one particular scale. So maybe from 0 to 1, maybe 0 to 1. That is nothing but normalization or standardization. In scaling technique, we will make the column scale free and unitless, which means it will be in one scale. Every value present in the column will be in one scale. So let us see this properly in CARS dataset. So let me open the Excel file that is present in the documents, I guess. Just give me a second. Here is my data set, which is empty CARS. Within this, I'll tell you this example of normalization, standardization, and drawbar scaling. And later we will see how to do that in RapidMiner as well. There are no columns present here. Okay, fine. Let me check the data sets. Our data set is not present in mine. Okay, fine. Let me create a sample one and I will check it out there. Okay, there are two columns. The first one that we have regarding this is speed and weight. You can take whatever you want, okay? Top speed and weight. So here I have values like, I will show for few records, okay? I will enter some random values and I will show it to you because I don't have the data set currently. So maybe I'll take a so I'm taking some random numbers, okay? I'm just okay, this here I got it as point. Here also I'll take it as point. Okay, I'll just copy this values and I'll paste it repeatedly. Okay, this I'm getting wrong. Okay, I have few records here. Just like that, I will write for weight as well. So I'll take here 28.4671, 30.2341. It's just some random values. 29.8912. Okay, I'll just copy this and paste it again. Okay, so these are the records present. Okay, now if you observe, I've entered only 15 records of data. Now, if I want to find out the mean of both the columns, the mean as well as standard deviation, I want to find out. So how to find out? How to find out here? The first column that we have is ST. Second one that we have is weight. Speed, that is SP. So here, how to find out mean? Mean you already know, you have to find out mean using average function. So is equals to average of this particular column. And click on enter. I got some average. And weight also. I will calculate this using average function, average and weight. I got the weight. Now, for this particular speed, top speed, I want to calculate the standard deviation. So I already told you standard deviation, we can calculate for a sample or a population, anything is fine. So I will calculate using the function stdev.s, which is a sample. Sample and this column. And also for this one, same again. Dot s of this column. Okay, now I got these values. After that, what? I have to standardize this value. So what is standardization and what is normalization? What is standardization and what is normalization? Before talking about it, we will talk about normalization first. I'll copy this and paste it here. We'll talk about this later. First, what is normalization formula? Normalization is nothing but x minus minimum of x divided by maximum of x minus minimum of x. What is the formula of normalization here? First, let us talk about normalization. So what is normalization? Normalization is nothing but x minus minimum of x divided by max of x minus min of x. So this is the formula for normalization. What is this formula is for? This is for normalization. So normalization is used in order to make it scale free and unitless, in order to bring all the values into a single scale. When we do this, when we normalize the data, after normalizing, the max value of that column will be 1 and the minimum value of that column will be 0. We will see this, how it happens. Okay, so here, see here, in order to understand this concept, in order to apply this formula, I should write or I should find minimum as well as maximum for both the columns. One is speed and second one is weight. So here, what is the function that I will use in order to find out minimum? Min function of this column. And for this one again, min function of weight column. And for this one again, max is equals to max of this particular column. And also for this, maximum of this particular column. So these are not present in a particular range. You can see here, this is not in the range. If I normalize this data, normalize these columns, my maximum value will become 1 and the minimum value will become 0. How we will see? Now I have to get the values for normalized speed values and also normalized weight values. How to get these values? So here we have to apply the formula. What is the formula? X is nothing but each and every individual record. So what is each and every individual record here? What is each and individual record is equals to X is this one for SP, this is the individual cell minus minimum of X. This is minimum divided by maximum of X minus minimum of X. Everybody understand what did I do? So here I'm writing the formula for every cell like this. B2 minus F2. B2 is the current cell minus minimum of X is nothing but the minimum value, which is 104 present in F2 cell, divided by maximum of X, which is again 113.46, which is present in F3 minus F2. Click on enter. So I got 0. And I have to apply this for every other cell. How to apply this for every other cell? So here also you have to do the same, which is this particular value minus minimum of X divided by maximum of X minus minimum of X. So I missed the parenthesis here. So I click on enter. So this is some other value. I want to apply this formula for every other cell. What I do is I'll fix the cells of F2, F3 and F2 because these are not going to change. Only these cells are going to change for which I want to get the normalized values. So I'm going to insert dollar symbols before column name and row number. How to insert dollar symbols? Click on function key and F4. And go to the cell or insert or keep your cursor here. Click on function key and F4. And for these as well. And click on enter. Now you have here the handle on the bottom right. You can double click on it. You will get the normalized values for the rest of the other records. So see, now you have to do that for the weight column as well. Now how to calculate for this one? The current value, which is X minus the minimum value divided by maximum value minus minimum value. And click on enter. Now you have to get for all the other cells as well. So you have to fix these cells. Function key and F4. For these as well, function key and F4. For these again, function key and F4. Now you have to drag the handle downwards. Then you will get the output. Now, after normalizing the values of both the columns, I want to check the minimum and maximum. The minimum and maximum for SP, which is normal SP, normalized column. And the next one, again for normal weight. Okay, how to calculate using min and max function is equals to minimum of, select the column which is normal SP, this one, click on enter. So minimum is always 0 when we normalize the data. As I told before, if you observe here, When I do the normalization, after normalization, my max will be always 1 and minimum will be always 0. And how to calculate maximum? You have to use the function max. Max of normal SP, click on enter. And do that for the weight as well. Minimum of this column normalized weight and again is equals to maximum of the column which is weight column. This is 1. This is how you will do the data scaling technique, the first one, which is normalization. So normalization is also called as min-max scalar method or range method. In here, when you normalize a particular column, after normalization, the minimum value in that column will be 0 and the maximum value in that column will be 1. This is about normalization. Let me clear the drawings. This is about normalization. Now, apart from the normalization, you also have standardization and drop-off scaling. So what is standardization and what is drop-off scaling? Okay, so here, standardization is nothing but it is based on mean and standard deviation. So what is based on mean and standard deviation? How can I understand this mean and standard deviation? Okay, let us go to the Excel. Now I will just work here. So everybody see, I've calculated the mean and standard deviation for both of the columns SP and weight. Now what is the formula for standardization? What is the formula for standardization? So standardization is the second data scaling method present. Standardization is equals to x minus mean of x minus mean of x divided by standard deviation of x. This is the formula. Now, what happens when you just apply this formula? So after standardizing the data, always the mean will be 0, which is very less, and standard deviation will be always 1. This is how you will scale the data in using standardization. Let's check it out. So here, I'll go back here and I will just write here, which is standard speed and standard weight. So what is standard speed and standard weight? You have to apply the formula. How to apply the formula? So each and every cell. So before writing that, you have to insert the parenthesis x minus mean of SP, which is this one, mean. And then what? Divided by standard deviation of speed. Enter. Enter. So if you want to get it properly, you can insert the parenthesis here as well, but that is not needed. Okay, you have to calculate this for every other cell. So in order to fix that, you have to fix these cells using function key and F4. Function key and F4. Click on enter. So check whether you have written everything right. Average, this is standard deviation, this is standard deviation, right? Now I will apply this formula for the rest of the cells as well. I got it. Now I have to find out the same thing for weight also is equals to the current value x minus mean, which is mean of weight, divided by standard deviation of weight column. And if you want to get this for all the other records also, you have to fix the formula. Function key and F4 and also here function key and F4. Now drag the formula downwards for all the other records, you will get the output. Now what did I talk about the standardization? When we standardize the columns, when we apply standardization, the mean for the standardized values will be 0, which is very less, and standard deviation will be 1. Let's calculate. Let's calculate mean and standard deviation for first standard speed and also standard weight. Okay, now here I will calculate the mean. Mean is nothing but average. You already know you have to use the average function for this standard speed column. This is very less. That is why it is showing in exponential format. I'll do the same thing for this one. Average of this particular column. And now here also, I will use stdev.s, which is for sample standard deviation for this column. And for this as well, I will just do the same thing. Standard deviation of sample for this column. So standard deviation is 1 and mean is 0. You may think like this is not 0. Why are you telling 0? So here this is nothing but exponential value. How can we write this as is? So I can write it as this value. I can write it as 2.81256 into 10 to the power of minus 16, which is very less, 0.00000 something, which is automatically equals to 0. Which is automatically equals to 0. If you want to get it, you can format it. How can you format it? How can you format it here? I will click on it, right click on it, and format cells. And here, if I check it out, if we format it under the number, and I want 16 decimal places, just a second, wait. So right click, format cells, let me show you whether that value is 0 or not. Number, and I want 16 decimal places or 17. So see, this is very least value. That is why it is showing like that. Okay, you can get the output when we perform standardization. You always get the mean as 0 and the standard deviation as 1. And when you perform normalization, always the minimum value will be 0 and the maximum value will be 1. Apart from these two, you also have some other technique called as robust scaling. So what is robust scaling? Where is that one here? So here, if you see the third one, you have your robust scaling. So robust scaling is mostly preferred when you have outliers in your data to scale your data. If you want to apply scaling technique, and if you are having outliers in that column, you can go for simply robust scaling. Because in here, we are using median, but in standard deviation, we are going for mean. So always prefer whatever you want according to your requirement. So these are the different scaling methods present. Normalization, which is also called as min-max scalar method or range method. In here, always the data, when we normalize it, the minimum will be 0 and the maximum will be 1. When we standardize that data, using this data scaling method, standardization, the mean will be always 0 and the standard deviation will be 1. And in robust scaling, we will prefer mostly the scaling technique when we have outliers in our data. Now let's see how to do this normalization and standardization in RapidMiner Studio. So let me go to that RapidMiner Studio here, and I will delete all the things that we have done before. I'm emptying my process. Now, within that sample folder where you have the default data sets present, I'm going to use Iris dataset. Iris dataset is the one which is already present in your default downloads or default datasets. So just drag it and drop it into the process. So Iris dataset I have. Now I want to observe the difference between the original data as well as the normalized and standardized data. So I have to use the function or the operator called as multiply. So I will connect the Iris dataset to the multiply data operator. Now I will use the operator called as normalize operator in order to normalize my data. So normalize operator is there. Now what I do is, first of all, I will connect the multiply output port to the response port in order to check the original output. Now this second output to input, as input to the normalize operator. Now, in order to customize, click on normalize, click on this operator. Now, I have to go for normalization, which means zeros and ones. I have to go for range transformation. Zeros and ones. I want to scale this data to be the minimum should be 0 and maximum should be 1. This is called as normalization, which I can do in RapidMiner Studio using normalize operator. Now, if I want to get the output, I have to just connect this to the response port and I have to execute the process. Now, this is the original data set. This is the normalized data set. You can check it out, the difference. Here, this is 500. These all things are present. When we check these values, the minimum will be always 0 and the maximum will be always 1. And after that, I want to do the standardization as well. So here again take normalize operator one more time. Again take normalize operator one more time and connect the output port of multiply again as input to the second normalize. Connect the output port of the multiply as input to the second normalize. You can change this operator name. How? Right click and rename the operator. I will rename it to standardize. I will rename it to standardize. But here you have to go for Z transformation, which is standardization, and connect this to the response port. This is how you can do the normalization and standardization, and using the multiply operator, you can understand the original data, and after normalization, what are the values present, and after standardization, what are the values present. You can understand in a single go. Execute this process. So this is the normal original data set, which is iris data. This one. This is the original values. And this is normalized data, which means the minimum will be 0 and the maximum will be 1 for all the columns. This is standardized, where the mean will be 0 and the standard deviation will be 1. According to your requirement, you can choose whatever the method or transformation technique that you want in RapidMiner Studio as well. So I'll give you 2 minutes. You can just understand this concept. I'll move on to the next one. This is how you will perform transformation in RapidMiner Studio. Now let's check it out. What is there further in the slides? Okay, so here, the next one that we have is feature selection. So feature selection, we will discuss about this in theory. So feature selection will help in dimensionality reduction. So feature selection technique helps in reducing the dimensionality of the data set. How? By selecting the most relevant features or the columns while discarding the irrelevant columns. What is it? This feature selection is a technique present which helps in reducing the dimensionality of the data set by selecting the most relevant features while discarding the irrelevant features. So there are different types of feature selection methods present. The first of all is intrinsic feature selection. What is it? So first of all, what is feature selection? Feature selection is the technique which helps in reducing the dimensionality. It helps in dimensionality reduction of data set. How? By selecting most relevant features or columns. By selecting most relevant features and by discarding the irrelevant ones, it will just reduce the dimensionality in the data set. Okay, so what are the different methods present? So the first one that we have is intrinsic feature selection. What is intrinsic feature selection? So here, automatically this intrinsic feature selection is performed by certain algorithms such as decision trees with which inherently select features based on their importance during model building. We will talk about decision trees briefly, but for now, understand the concept. So here we have the first one, that is intrinsic feature selection. So that is the first one, that is intrinsic feature selection. So here we are not doing anything in this particular concept of feature selection. So here automatically the algorithm, the certain machine learning algorithm called as decision tree, it will automatically select the features which are important based on the analysis that it was done during model building. So example called as decision trees. So it will automatically select the features or the columns which are important during the model building. That is called as intrinsic feature selection. And the second one that we have is filter methods. What is it? The second one that we have is filter methods. So what do you mean by filter methods? What do you mean by filter methods? So here, we will establish the relationship between the input features and the target variable without involving any machine learning algorithms. So there is another method present in the feature selection, that is filter methods. Here, we will establish the relationship between the input variables and the target variables. Here, we will not involve any machine learning algorithm. Here, we will not involve any machine learning algorithm. That is nothing but filter method. And in filter method again, you have different examples, like first one that we have is statistical based feature selection. What is statistical based methods? What is statistical based feature selection? So here also again, we will utilize some statistical metrics to evaluate the relationship between input and target. Here we will use some statistical metrics. So based on that, we will find out the relationship, within which again we have multiple different types like correlation coefficient, mutual information, something like that. And the next one, the next important thing that we have is hypothesis testing. Mutual information and hypothesis testing. Within this again, you have chi-square test and ANOVA test. And iterative feature selection is present. Here it involves repeatedly building the models with different subset of features. Here in iterative feature selection, it involves repeatedly building the models with different subsets of features. And it will select the subsets that will yield the best performance. That is iterative feature selection. So these are the theoretical things that are present. You should remember. We will discuss everything which is decision tree, all these things, machine learning algorithms in the next session. Let me clear and see what is present next. So again, we have some other methods like wrapper methods, which is recursive feature elimination and feature importance scores and various other things. So up to this, we have completed our module for today. So we will see overall what we have seen in today's session. Okay, let us go back to the first one, where we have discussed about data cleansing and organizing. So what is data cleansing and organizing? So here, when we are recording the information, we will have some junk present. We will eliminate that junk and we will clean the data. That is data cleansing. And coming to the data organizing, wherever the data which is present in unstructured format, we will convert it into structured format with the help of data organizing method. Data cleansing and data organizing. And then coming to the next one, we have the next one, that is typecasting, which is also called as type conversion or type coercion or type juggling. And the next one, that is handling duplicates. So we have various methods of handling the duplicates. The first one is you can add the duplicates and get the meaningful information. If not, you can delete the duplicate rows or duplicate columns. Anything is fine. Now, the next one we have is outlier analysis. So in outlier analysis, basically, we have again different treatments present, out of which the first one is 3R technique. 3R stands for rectify, retain, and remove. So depending upon your purpose, you can go for whatever you want. Okay. Now again, you have Vincerization, where you will take a value. Based on that, you will replace the values with the percentile that you have taken. And trimming is where you will take an alpha value. Whichever that are less than that alpha value will be trimmed off. And whichever that are greater than another percentile will also be trimmed off. And again, swamping and masking are there. And to identify the outliers, we can use standard deviation approach or IQR approach as well. Okay. And then we have zero variance or near zero variance features. Whichever the columns that is having a single value, that is called as zero variance. Whatever the columns that are having two categories, in which one category is having most of the proportion, that is called as near zero variance. And when we are dealing with categorical columns, you will go for proportion. When we are dealing with numerical columns, you will go for variance. Coming to the discretization, converting numerical into categorical is called discretization. If we are converting into two categories, that is called binarization. And rounding it off to a certain number, either floor number or ceiling number, is called rounding. And instead of converting it into different categories, if it is converting it into bins, it is called as binning. Binning is also called as grouping. And in binning, we have again two types, fixed width binning and adaptive binning. So fixed width binning is that in here, we will tell specifically how many bins I want. But in adaptive binning, we will leave it to the algorithm to tell whether how many bins it is going to create. That is adaptive binning. Next, we have is encoding. Encoding is nothing but converting categorical columns into numerical columns. So here we have one hot encoding, which is also called as binary encoding. And we also have ordinal encoding, which is also called as label encoding. And we also have attribute construction. When we are having inputs, based on the present inputs, I'm going to create new ones that is called as attribute construction. And then we also have as dummy variable creation that I told you. The difference between one hot encoding and dummy variable creation is that if we are having n levels in a factor, then in dummy variable creation, n minus 1 variables will be created. But in one hot encoding, n variables will get created. And coming to this attribute construction, I told you an example of credit card. And missing values, there are 3 variants. Missing completely at random, missing at random, missing not at random. So based on the reason, if it is known, if it is certain, whether it is guessed, it is unknown, we have 3 different variants. And also dealing with that, we have deletion methods in which we have simple strategies, which is case-wise deletion and pair-wise deletion. And after that, we have again some methods of imputation present. Simple imputation methods, which are statistical imputations, mean, median, mode, random, and also hot deck. Apart from them, we have others, which we will discuss when we are talking about predictive modeling. And data transformations can be different types, log, and also you have exponential, and you also have power, which can be square or cube, and polynomial, reciprocal, Box-Cox, and also Eo-Johnson. Box-Cox is preferred when you have positive values, and Eo-Johnson is preferred when you have zeros as well as negatives. And data scaling, normalization, standardization, and dropper scaling. And the last one that we have is feature selection. So everything I've shown you, every step, how to perform in RapidMiner Studio as well. So in order to understand what operator is working and what is the purpose of every operator, you should have some theoretical knowledge. That is why we are discussing about all of these things. And we will just see the mind map, whether we have missed something. Yeah, we did not talk about feature scaling. Let us open the feature scaling and talk about it. So feature scaling, it will make the data scale-free and unitless, which has 3 types: standardized scaling, which is x minus mean by standard deviation. In here, mean will be 0 and standard deviation will be 1. Min-max scaling or range is also called as normalization. The formula is x minus minimum of x divided by maximum of x minus minimum of x. Here, the minimum will be 0 and the maximum will be 1. Robust scaling here, it will be preferred when we have outliers in the data, x minus median divided by IQR. Here we are using median, which will not get influenced by the outliers. That is why we will prefer robust scaling when we are working on data which is having outliers. So this is about data pre-processing or data preparation or data cleansing. You can call it anything you want. Within this, we have completed this data preparation. And in the next session, which is at 10 o'clock tomorrow, we will start discussing about the model building, which is what do you mean by supervised, unsupervised, what are the differences present. We will talk about all those things in tomorrow's session, which will be again at 10 o'clock. I hope this session is helpful for you. Thank you, everybody.